Chapter 6 of Aviation Instructor's Handbook by the FAA. This LibriVox recording is in the public domain. Chapter 6 Planning Instructional Activity. Introduction. Susan, student, and Bill, certificated flight instructor, CFI, are flying a lesson scenario which consists of a short cross-country leg to a local airport for some practice landings, followed by a return to the home airport located in Class C airspace. While practicing landings at the non-towered airport, the student notes that the ceiling is lowering and the crosswind is beginning to increase. In his own mind, Bill is convinced they can practice landings for another 30 minutes to an hour and still return to home base. However, instead of telling Susan this, while taxiing back after a full-stop landing, he first asks her several questions. Has the flight situation changed since they left the home field? What does she think of the weather situation? How can we gain more information? Check with the Automated Flight Service Station, AFSS, on the radio. Stop at the Fixed-Base Operator, FBO, and call back to the FBO to check on weather and the schedule. Are there other issues? Fuel? Schedule? Aircraft equipment, instrument flight rules IFR/visual flight rules VFR, and pilot capability? Susan decides she would be more comfortable returning to the home airport and practicing landings there to stay out of the weather. Although not his plan, it is a good plan based on accurate situational awareness and good risk management skills, so Bill agrees. Susan is now beginning to gain confidence by practicing her judgment and decision-making skills. In the post-flight critique, Susan leads a discussion of this and other decisions she has made in order to learn more about the process. In the past, the aviation instructor was a capable pilot or aviation technician with a rather general understanding of basic teaching methods and techniques. More recently, the Federal Aviation Administration, FAA, has paid more attention to the instructor's role as teacher and mentor, and has provided a much better grounding in instructional techniques. The instructor is now required to master the teaching methods, write lesson objectives, outline and write lesson plans, and motivate students by example. The instructor is responsible for what is taught in the aircraft and classroom. The amount of learning that takes place is a direct result of how well the lesson is prepared and the teaching skill of the instructor. Historically, aviation instruction focused on the performance of specific procedures and/or maneuvers, and learning was measured with objective standards. Changing technology and innovations in learning provide today's aviation instructors with the opportunity to use new methods and teach to new standards. One of these methods, introduced in Chapter 4, The Teaching Process, is scenario-based training, SBT. While SBT is an integral component of today's aviation training, the instructor is crucial to its implementation. By emphasizing SBT, the instructor functions in the learning environment as an advisor and guide for the learner. Whatever the method of teaching, the key to developing well-planned and organized aviation instruction includes using lesson plans and a training syllabus that meet all the regulatory certification requirements. Much of the basic planning necessary for the flight instructor and maintenance instructor is provided by the knowledge and proficiency requirements published in Title 14 of the Code of Federal Regulations, 14 CFR, Parts 61 and 65, approved school syllabi, and the various texts, manuals, and training courses available. This chapter reviews the planning required by the professional aviation instructor as it relates to 4 key topics: course of training, blocks of learning, training syllabus, and lesson plans. It also explains how to integrate SBT, aeronautical decision-making, ADM, and risk management into the aviation training lesson. Course of training. As discussed in Chapter 4, a course of training is a series of studies leading to attainment of a specific goal, such as a certificate of completion, graduation, or an academic degree. An instructor plans instructional content around the course of training by determining the objectives and standards, which in turn determine individual lesson plans, test items, and levels of learning. For complete discussion of determining these items, see Chapter 4. Blocks of learning. After the overall training objectives have been established, the next step is the identification of the blocks of learning which constitute a necessary part of the total objective. Just as in building a pyramid, some blocks are submerged in the structure and never appear on the surface, but each is an integral and necessary part of the structure. Thus, the various blocks are not isolated subjects, but essential parts of the whole. During the process of identifying the blocks of learning to be assembled for the purpose of training activity, the instructor must also examine each block to ensure it is an integral part of the structure. Extraneous blocks of instruction are expensive frills, especially in flight instruction, and detract from, rather than assist in, the completion of the final objective. While determining the overall training objectives is a necessary first step in the training process, early identification of the foundation blocks of learning is also essential. Training for any such complicated and involved task as piloting or maintaining an aircraft requires the development and assembly of many segments or blocks of learning in their proper relationships. In this way, a student can master the segments or blocks individually and can progressively combine these with other related segments until their sum meets the overall training objectives. The blocks of learning identified during the planning and management of a training activity should be fairly consistent in scope. They should represent units of learning which can be measured and evaluated, not a sequence of periods of instruction. For example, the flight training of a private pilot might be divided into the following major blocks: achievement of the knowledge and skills necessary for solo, the knowledge and skills necessary for solo cross-country flight, and the knowledge and skills appropriate for obtaining a private pilot certificate. Figure 6-1. Use of the building block approach provides the student with a boost of self-confidence. This normally occurs each time a block is completed. Otherwise, an overall goal, such as earning a mechanic's certificate, may seem unobtainable. If the larger blocks are broken down into smaller blocks of instruction, each on its own is more manageable. Humans learn from the simple to the complex. For example, a student airplane pilot should understand and master the technique of a normal landing prior to being introduced to short and soft field landings. A helicopter pilot must be proficient in running landings before the instructor introduces a no hydraulics approach in landing. By becoming familiar with the student's aviation background, an instructor can plan the sequence of instruction blocks. Does the applicant have previous aeronautical experience or possess a pilot certificate in another category? This information will help the instructor design appropriate training blocks. For example, if the student is a helicopter pilot who is transitioning to an airplane, he or she will understand speed control, but not necessarily know how to achieve it in an airplane. The instructor can plan blocks of instruction that build on what the student already knows. Training syllabus. Aviation instructors use a training syllabus because as technology advances, training requirements become more demanding. At the same time, new and often more complicated rules continue to be proposed and implemented. In addition, the rules for instruction in other than an approved aviation school are still quite specific about the type and duration of training. These factors, along with the continuing growth of aviation, add to the complexity of aviation training and certification. Instructors need a practical guide to help them make sure the training is accomplished in a logical sequence and that all the requirements are completed and properly documented. A well-organized, comprehensive syllabus can fill these needs. Syllabus format and content. The format and organization of the syllabus may vary, but it should always be in the form of an abstract or digest of the course of training. It should contain blocks of learning to be completed in the most efficient order. Since a syllabus is intended to be a summary of a course of training, it should be fairly brief, yet comprehensive enough to cover essential information. This information is usually presented in an outline format with lesson-by-lesson coverage. Some syllabi include tables to show recommended training time for each lesson, as well as the overall minimum time requirements. Figure 6-2. While many instructors may develop their own training syllabi, There are many well-designed commercial products that may be used. These are found in various training manuals, approved school syllabi, and other publications available from industry. Syllabi developed for approved flight schools contain specific information that is outlined in 14 CFR Parts 141 and 142. In contrast, syllabi designed for training in other than approved schools may not provide certain details, such as enrollment prerequisites, planned completion times, and descriptions of checks and tests to measure student accomplishments for each stage of training. Since effective training relies on organized blocks of learning, all syllabi should stress well-defined objectives and standards for each lesson. Appropriate objectives and standards should be established for the overall course, the separate ground and flight segments, and for each stage of training. Other details may be added to a syllabus in order to explain how to use it and describe the pertinent training and reference materials. Examples of the training and reference materials includes textbooks, video, compact discs, exams, briefings, and instructional guides. How to use a training syllabus. Any practical training syllabus must be flexible and should be used primarily as a guide. Figure 6-3. When necessary, the order of training can and should be altered to suit the progress of the student and the demands of special circumstances. For example, previous experience or different rates of learning often require some alteration or repetition to fit individual students. The syllabus should also be flexible enough so it can be adapted to weather variations, aircraft availability, and scheduling changes without disrupting the teaching process or completely suspending training. In departing from the order prescribed by the syllabus, however, it is the responsibility of the instructor to consider how the relationships of the blocks of learning are affected. For example, if the student is having a difficult time with normal approaches and landings, the instructor might decide to delay adding short field landings, which were originally to be the next step in his block of instruction. To prevent the student from becoming frustrated with his or her poor landing technique, the instructor may choose to review the block on slow flight, which offers the student a chance to do well and regain confidence. This exercise also builds the skills necessary for the student to master approaches and normal landings. Each approved training course provided by a certificated aviation school should be conducted in accordance with a training syllabus specifically approved by the FAA. At certificated schools, the syllabus is a key part of the training course outline. The instructional facilities, airport, aircraft, and instructor personnel must be able to support the course of training specified in the syllabus. Compliance with the appropriate approved syllabus is a condition for graduation from such courses. Therefore, effective use of a syllabus requires that it be referred to throughout the entire course of training. Both the instructor and the student should have a copy of the approved syllabus. However, as previously mentioned, adherence to a syllabus should not be so stringent that it becomes inflexible or unchangeable. It must be flexible enough to adapt to the special needs of individual students. Ground training lessons and classroom lectures concentrate on the cognitive domain of learning. A typical lesson might include defining, labeling, or listing what the student has learned so far. Many of the knowledge areas are directly or indirectly concerned with safety, ADM, and judgment. Since these subjects are associated with the affective domain of learning, emotion, instructors who find a way to stress safety, ADM, and judgment, along with the traditional aviation subjects, can favorably influence a student's attitude, beliefs, and values. Flight training lessons or aviation technical lab sessions also include knowledge areas, but they generally emphasize the psychomotor domain of learning because the student is doing something. The lesson plan, shown in Figure 6-4, shows the main elements of a ground lesson for a flight student. The affective domain of learning is also important in this type of training. A student's attitude toward safety, ADM, and judgment should be a major concern of the instructor. The flight training syllabus should include special emphasis items that have been determined to be cause factors in aircraft accidents or incidents. For example, the instructor should emphasize collision and wake turbulence avoidance procedures throughout a student's flight training. The aviation technician syllabus should also emphasize what constitutes unsafe practices, such as the ease of introducing foreign object damage, FOD, to an aircraft when the location of tools is not monitored. A syllabus may include several other items that add to or clarify the objective, content, or standards. A lesson may specify the recommended class time, reference or study materials, recommended sequence of training, and study assignment for the next lesson. Both ground and flight lessons may have explanatory information notes added to specific lessons. Figure 6-5. While a syllabus is designed to provide a roadmap showing how to accomplish the overall objectives of a course of training, it may be useful for other purposes. As already mentioned, it can be used as a checklist to ensure that required training has successfully been completed. Thus, a syllabus can be an effective tool for record keeping. Enhanced syllabi, which are also designed for record keeping, can be very beneficial to the independent instructor. This record-keeping function is usually facilitated by boxes or blank spaces adjacent to the knowledge areas, procedures, or maneuvers in a lesson. Most syllabi introduce each procedure or maneuver in one lesson and review them in subsequent lessons. Some syllabi include provisions for grading student performance and recording both ground and flight training time. Accurate record keeping is necessary to keep both the student and instructor informed of the status of training. These records also serve as a basis for endorsements and recommendations for knowledge and practical tests. Some training syllabi or records may include coded numbers or letters for other instructors to record their evaluation of a student's progress and knowledge or skill level. Figure 6-6. Another benefit of using a syllabus is that it helps the development of lesson plans. A well-constructed syllabus already contains much of the essential information that is required in a lesson plan, including objectives, content, and completion standards. Lesson plans. A lesson plan is an organized outline for a single instructional period. It is a necessary guide for the instructor because it tells what to do, in what order to do it, and what procedure to use in teaching the material of a lesson. Lesson plans should be prepared for each training period and be developed to show specific knowledge and/or skills to be taught. A mental outline of a lesson is not a lesson plan. A lesson plan should be put into writing. Another instructor should be able to take the lesson plan and know what to do in conducting the same period of instruction. Written out, the lesson plan can be analyzed for adequacy and completeness. Lesson plans make excellent record-keeping forms that can become a permanent part of a pilot's training record. They can be formatted for the instructor to carry in the aircraft and include a checklist for indicating what portions of the lesson were completed, date of completion, the flight instructor's signature, and time flown. The lesson plan can also have a notation section for flight instructor comments. A training folder for each student helps an instructor keep all pertinent data in one place. The folder should include items such as lesson plans, training requirements, flight or ground instruction received, 14 CFR Part 61 requirements met, solo endorsements, and any other training information. These records should be kept in a safe place for at least 3 years. Good record keeping also provides an instructor with the number of students he or she has trained, which is helpful information for an instructor who needs to renew his or her certificate. For sample lesson plans, please refer to Appendix A. Purpose of the lesson plan. Lesson plans are designed to assure that each student receives the best possible instruction under the existing conditions. Lesson plans help instructors keep a constant check on their own activity as well as that of their students. The development of lesson plans by instructors signifies, in effect, that they have taught the lessons to themselves prior to attempting to teach the lessons to students. An adequate lesson plan, when properly used, should assure a wide selection of material and the elimination of unimportant details, make certain that due consideration is given to each part of the lesson, aid the instructor in presenting the material in a suitable sequence for efficient learning, provide an outline of the teaching procedure to be used, serve as a means of relating the lesson to the objectives of the course of training, Give the inexperienced instructor confidence. Promote uniformity of instruction regardless of the instructor or the date on which the lesson is given. Characteristics of a well-planned lesson. The quality of planning affects the quality of results. Successful professionals understand that the price of excellence is hard work and thorough preparation. The effective instructor realizes that the time and energy spent in planning and preparing each lesson is well worth the effort in the long run. A complete cycle of planning usually includes several steps. After the objective is determined, the instructor must research the subject as it is defined by the objective. Once the research is complete, the instructor determines the method of instruction and identifies a useful lesson planning format. The decision of how to organize the lesson and the selection of suitable support material come next. The final steps include assembling training aids and writing the lesson plan outline. One technique for writing the lesson plan outline is to prepare the beginning and ending first. Then complete the outline and revise as required. A lesson plan should be a working document that can and should be revised as changes occur or are needed. The following are some of the important characteristics that should be reflected in all well-planned lessons. Unity. Each lesson should be a unified segment of instruction. A lesson is concerned with certain limited objectives which are stated in terms of desired student learning outcomes. All teaching procedures and materials should be selected to attain these objectives. Content. Each lesson should contain new material. However, the new facts, principles, procedures, or skills should be related to the lesson previously presented. A short review of earlier lessons is usually necessary, particularly in flight training. Scope. Each lesson should be reasonable in scope. A person can master only a few principles or skills at a time, the number depending on complexity. Presenting too much material in a lesson results in confusion. Presenting too little material results in inefficiency. Practicality. Each lesson should be planned in terms of the conditions under which the training is to be conducted. Lesson plans conducted in an airplane or ground trainer will differ from those conducted in a classroom. Also, the kinds and quantities of instructional aids available have a great influence on lesson planning and instructional procedures. Flexibility. Although the lesson plan provides an outline and sequence for the training to be conducted, a degree of flexibility should be incorporated. For example, the outline of content may include blank spaces for add-on material if required. Relation to course of training. Each lesson should be planned and taught so that its relation to the course objectives is clear to each student. For example, a lesson on short field takeoffs and landings should be related to both certification and safety objectives of the course of training. Instructional steps. Every lesson, when adequately developed, falls logically into the 4 steps of the teaching process: preparation, presentation, application, and review and evaluation. How to use a lesson plan properly. Be familiar with the lesson plan. The instructor should study each step of the plan and should be thoroughly familiar with as much information related to the subject as possible. Use the lesson plan as a guide. The lesson plan is an outline for conducting an instructional period. It assures that pertinent materials are at hand and that the presentation is accomplished with order and unity. Having a plan prevents the instructor from getting off track, omitting essential points, and introducing irrelevant material. Students have a right to expect an instructor to give the same attention to teaching that they give to learning. The most certain means of achieving teaching success is to have a carefully reviewed lesson plan. Adapt the lesson plan to the class or student. In teaching a class, the instructor may find that procedures outlined in the lesson plan are not leading to the desired results. In this situation, the instructor should change the approach. There is no certain way of predicting reactions of different groups of students. An approach that has been successful with one group may not be equally successful with another. A lesson plan for an instructional flight period should be appropriate to the background, flight experience, and ability of the particular student. A lesson plan may have to be modified considerably during flight due to deficiencies in the student's knowledge or poor mastery of elements essential to the effective completion of the lesson. In some cases, the entire lesson plan may have to be abandoned in favor of review. Revise the lesson plan periodically. After a lesson plan has been prepared for a training period, a continuous revision may be necessary. This is true for a number of reasons, such as availability or non-availability of instructional aids, changes in regulations, or new manuals and textbooks. Lesson plan formats. The format and style of a lesson plan depends on several factors. Certainly, the subject matter helps determine how a lesson is presented and what teaching method is used. Individual lesson plans may be quite simple for one-on-one training, or they may be elaborate and complicated for large, structured classroom lectures. Preferably, each lesson should have somewhat limited objectives that are achievable within a reasonable period of time. This principle should apply to both ground and flight training. However, as previously noted, aviation training is not simple. It involves all three domains of learning, and the objectives usually include the higher levels of learning, at least at the application level. In spite of need for varied subject coverage, diverse teaching methods, and relatively high-level learning objectives, most aviation lesson plans have the common characteristics already discussed. All should include objectives, content to support the objectives, and completion standards. Various authorities often divide the main headings into several subheadings. Terminology, even for the main headings, varies extensively. For example, completion standards may be called assessment, review, and feedback, performance evaluation, or some other related term. Commercially developed lesson plans are acceptable for most training situations, including use by flight instructor applicants during their practical tests. However, all instructors should recognize that even well-designed pre-printed lesson plans may need to be modified. Therefore, instructors are encouraged to use creativity when adapting pre-printed lesson plans or when developing their own lesson plans for specific students or training circumstances. In the traditional lesson plan illustrated by Figure 6-7, the objective is the student will learn to control for wind drift. The content has the instructor pilot giving a thorough coverage of heading, speed, angle of bank, altitude, terrain, and wind direction plus velocity. This explanation is followed by a demonstration and repeated practice of a specific flight maneuver, such as turns around a point or S-turns across the road, until the maneuver can be consistently accomplished in a safe and effective manner within a specified limit of heading, altitude, and airspeed. At the end of the lesson, the student is only capable of practicing the maneuver with assistance from the instructor. The traditional type of training lesson plan, with its focus on the task and maneuver or procedures, continues to meet many aviation learning requirements, but as discussed earlier in the chapter, it has been augmented by more realistic and fluid forms of problem-based learning, such as SBT. For the CFI, this type of training does not preclude traditional maneuver-based training. Rather, flight maneuvers are integrated into the flight scenarios and conducted as they would occur in the real world. Those maneuvers requiring repetition are still taught during concentrated settings. Once learned, they are then integrated into realistic flight situations. For the aviation technician instructor, SBT enhances traditional classroom instruction. By integrating SBT into the lesson, students are required to deal with problems they will encounter in the real world. Scenario-based training, SBT. Improper pilot decisions cause a significant percentage of all accidents and the majority of fatal accidents in light, single, and twin-engine aircraft. The goal of SBT is to challenge the student or transitioning pilot with a variety of flight scenarios to improve decision-making skills. These scenarios require the pilot to manage the resources available in the flight deck, exercise sound judgment, and make timely decisions. As defined in Chapter 4, SBT is a training method that uses a highly structured script of real-world experiences to address aviation training objectives in an operational environment. Such training can include initial training, transition training, upgrade training, recurrent training, and special training. Since humans develop cognitive skills through active interaction with the world, An effective aviation instructor uses the maneuver or procedure-based approach of the PTS, but presents the objectives in a scenario situation. Although some CFIs have used the SBT approach as a teaching method for many years, the recent emphasis on SBT in aviation training reflects education research that shows students learn more effectively when actively involved in the learning process. The introduction of advanced avionics is also a factor. Advanced avionics have changed the role of general aviation, GA, from an industry dominated by pleasure flying to a viable alternative to the scheduled airlines. With glass displays, GPS, and autopilot, advanced avionics may allow easier and safer operation, but are more complex. Advanced avionics have contributed to a shift in the focus of aviation training to include aeronautical decision-making, ADM, and risk management. For the pilot, this is called Single Pilot Resource Management, SRM. Since SRM training requires the student or transitioning pilot to practice the decision-making process in real-world situations, it combines traditional task and maneuver-based training with SBT to enhance ADM, risk management, and SRM skills without compromising basic stick and rudder skills. Instead of training pilots to pass practical tests, this program focuses on expertly managed real-world challenges. Duties, responsibilities, and authority of the aviation instructor. The duties, responsibilities, and authority of the aviation instructor include the following. 1. Orient new learners in the SBT approach. 2. Help the learner become a confident planner and a critical evaluator of his or her own performance. 3. Help the learner understand the knowledge requirements present in real-world applications. 4. Diagnose learning difficulties and help the individual overcome them. 5. Evaluate student progress and maintain appropriate records. 6. Provide continuous review of student learning. The aviation instructor is the key to the success of SBT. Remember, the overall learning objective is for the student to be ready to exercise sound judgment and make good decisions. For example, the flight instructor must be ready to turn the responsibility for planning and execution of the flight over to the student as soon as possible. The flight instructor continues to demonstrate and instruct skill maneuvers in the traditional manner, but when the student begins to make decisions, the flight instructor should revert to the role of mentor and/or learning facilitator. A situation a student faces may not have one right or one wrong answer. Instead, a student encounters situations in training that may have several good outcomes and a few poor ones. Rather than requiring the student to make a decision that matches the instructor's personal preference, he or she should understand in advance which outcomes are positive and/or negative and give the student the freedom to make both good and poor decisions. This does not mean that the student should be allowed to make an unsafe decision or commit an unsafe act. However, it does allow the student to make decisions that fit his or her experience level and result in positive outcomes. SBT Lesson Plan. The SBT lesson plan differs from the traditional lesson plan, Figure 6-8. In this example, the instructor pilot tells the student to plan for arrival at a specific non-towered airport. The planning should take into consideration the possible wind conditions, arrival paths, airport information and communication procedures, available runways, recommended traffic patterns, courses of action, and preparation for unexpected situations. Upon arrival at the airport, the student makes decisions, with guidance and feedback as necessary, to safely enter and fly the traffic pattern. This is followed by a discussion of what was done, why it was done, the consequences, other possible courses of action, and how it applies to other airports. In contrast to the student who trained under the traditional lesson plan, the student who trains under the SBT format is not only capable of a specific flight maneuver, he or she is now capable of detailing the safe arrival at any non-towered airport in any wind condition. Pre-scenario planning. For SBT instruction to be effective, it is vital that the aviation instructor and student establish the following information. Flight scenario. scenario destinations, desired student learning outcomes, desired level of student performance, possible in-flight scenario changes. Non-flight scenario, narrative of the task goal, desired student learning outcomes, desired level of student performance, possible scenario changes. The aviation industry is moving from traditional knowledge-related learning outcomes to an emphasis on increased internalized learning in which learners assess situations and react appropriately. Knowledge components are becoming an important side effect of a dynamic learning experience. Reality is the ultimate learning situation, and SBT attempts to get as close as possible to this ideal. It addresses learning that occurs in a context or situation. It is based on the concept of situated cognition, which is the idea that knowledge cannot be known and fully understood independent of its context. In other words, humans learn better the more realistic the situation is and the more they are counted on to perform. For example, realistic cross-country flight scenarios planned and executed by the pilot in training with assistance from the flight instructor begin the early development of flight deck management skills, situational awareness, and ADM. Continued engagement by the student in the planning, executing, and assessment of each scenario reinforces it throughout the training. It is important to remember the student is responsible for planning the flight scenario from a menu of short cross-country flights developed by the training provider. While the flight instructor will certainly assist the student in aircraft performance data, weight and balance, and general aircraft layout prior to the first lesson, the sooner the student assumes these responsibilities, the better the learning environment. The scenario descriptions offered by the FAA generic syllabi are a starting point for the training provider. Scenarios can be tailored for the local weather and terrain conditions, and are most effective when they replicate the environment most likely encountered by the students. SBT is a compilation of basic learning theory, adult learning concepts, and the best of the traditional aviation training procedures. Above all, it is about learning complex tasks in a realistic environment at a pace and in a structure the individual student can comprehend and process. Figure 6-9. Good teaching techniques are still important, but only if they aid in student learning. More detailed information about SBT can be found at www.faa.gov/education_research/training/FITS. Figure 6-9 Caption: Points to remember about scenario-based training. Figure 6-9 Text: The main points to remember about scenario-based training. SBT is situated in a real context and is based on the idea that knowledge cannot be gained and fully integrated independent of its context. SBT accords with a performance improvement and behavior change philosophy of the learning function. SBT is different from traditional instructional design. One must be aware of the differences to successfully employ SBT. Most learning solutions should employ both traditional training and SBT. Traditional learning elements should enhance the SBT elements. It is essential to place boundaries around scenarios to make the transition between scenarios and traditional learning as efficient as possible. Open-ended, qualitative learner feedback is key to successful scenario revision, but revisions should not further complicate the scenario unless highly justified. End of Figure 6-9 text. Single Pilot Resource Management. SRM is the art and science of managing all the resources, both on board the aircraft and from outside sources, available to a single pilot, prior and during flight, to ensure that the successful outcome of the flight is never in doubt. The emergence of very light jet, VLJ, aircraft will revolutionize the way America travels. Figure 6-10. Central to their economic success is the concept of single-pilot operations. Since the aircraft is heavily automated, the pilot's workload may actually be less than the current workload in a high-performance single-engine aircraft of today. This allows more time for the pilot to gather and analyze information about weather, winds, landing conditions, fuel state, pilot physical condition, and passenger desires. However, unless the pilot is trained to manage all these factors and to let the aircraft automation assist, the workload may be very high. SRM training helps the pilot maintain situational awareness by managing the automation and associated aircraft control and navigation tasks. This enables the pilot to accurately assess, manage risk, and make accurate and timely decisions. SBT enhances SRM because SBT helps pilots learn how to gather information, analyze it, and make decisions. Chapter Summary. As indicated by this chapter, it is possible to develop well-planned and organized instructions by using a training syllabus and lesson plans that meet all regulatory certification requirements. By identifying and incorporating blocks of learning into the teaching of objectives, the instructor can plan lessons that build on prior knowledge. Maneuver and/or procedure training, coupled with SBT, will help the aviation instructor train professional aviators and technicians who are able to gather and analyze information to aid in making good aeronautical decisions and decrease risk factors, leading to a successful flight or maintenance outcome. As this training program evolves and new resources are introduced, aviation instructors will have immediate web-based access to documents, such as the generic transition syllabus through http://www.faa.gov/. Another useful website for SBT is www.faa.gov/training/fits/training/flight_instructor/media/volume1.pdf. End of Chapter 6. Chapter 7 of Aviation Instructor's Handbook by the FAA. This LibriVox recording is in the public domain. Chapter 7, Instructor Responsibilities and Professionalism. Introduction. Since students look to aviation instructors as authorities in their respective areas, it is important that instructors not only know how to teach, but that they project a knowledgeable and professional image. This chapter addresses the responsibilities of aviation instructors in the training process and role as safety advocates, discusses how aviation instructors can enhance their professional image, and offers suggestions and sources for information to assist in professional development. Aviation Instructor Responsibilities. The job of an aviation instructor is to teach. Previous chapters have discussed how people learn, the teaching process, and teaching methods. As indicated, the learning process can be made easier by helping students learn, providing adequate instruction to meet established standards, measuring student performance against those standards, and emphasizing the positive. Figure 7-1. Helping students learn. Learning should be an enjoyable experience. By making each lesson a pleasurable experience for the student, the instructor can maintain a high level of student motivation. This does not mean the instructor makes things easy for the student or sacrifices standards of performance to please the student. The student experiences satisfaction from doing a good job or from successfully meeting the challenge of a difficult task. The idea that people must be led to learning by making it easy is a fallacy. Though students might initially be drawn to less difficult tasks, they ultimately devote more effort to activities that bring rewards. The use of standards and measurement against standards is key to helping students learn. Meeting standards holds its own satisfaction for students. People want to feel capable, and they are proud of the successful achievement of difficult goals. Learning should be interesting. Knowing the objective of each period of instruction gives meaning and interest to the student as well as the instructor. Not knowing the objective of the lesson often leads to confusion, disinterest, and uneasiness on the part of the student. Providing adequate instruction. To tailor his or her teaching technique to the student, The flight instructor analyzes the student's personality, thinking, and ability. No two students are alike, and a particular method of instruction cannot be equally effective for all students. The instructor talks with a student at some length to learn about the student's background, interests, temperament, and way of thinking, and is prepared to change his or her method of instruction as the student advances through successive stages of training. An instructor who incorrectly analyzes a student may find the instruction does not produce the desired results. For example, the instructor at first thinks the student is not a quick learner because the student is quiet and reserved. Such a student may fail to act at the proper time due to lack of self-confidence, even though the situation is correctly understood. In this case, instruction is directed towards developing student confidence rather than drill on flight fundamentals. In another case, too much criticism may discourage a timid person, whereas brisk instruction may force a more diligent application to the learning task. A student requiring more time to learn also requires instructional methods that combine tact, keen perception, and delicate handling. If such a student receives too much help and encouragement, a feeling of incompetence may develop. A student whose slow progress is due to discouragement and a lack of confidence should be assigned sub-goals that can be attained more easily than the usual learning goals. For this purpose, complex lessons should be separated into elements and each element practiced until an acceptable performance is achieved before the whole maneuver or operation is attempted. For example, instructions in S-turns may begin with consideration for headings only. Elements of altitude control, drift correction, and coordination can be introduced one at a time. As the student gains confidence and ability, goals are increased in difficulty until progress is normal. Conversely, students who are fast learners can also create challenges for the instructor. Because these students make few mistakes, they may assume that the correction of errors is unimportant. Such overconfidence can result in faulty performance. For these students, the instructor constantly raises the standard of performance for each lesson, demanding greater effort. Individuals learn when they are aware of their errors. Students who are permitted to complete every flight lesson without corrections and guidance will not retain what they have practiced as well as those students who have their attention constantly directed to an analysis of their performance. On the other hand, deficiencies should not be invented solely for the student's benefit because unfair criticism immediately destroys their confidence in the instructor. In some ways, an aviation instructor serves as a practical psychologist. As discussed in chapters 1 and 2, an instructor can meet this responsibility through a careful analysis of and continuing interest in students. Most new instructors tend to adopt the teaching methods used by their own instructors. The fact that one has learned under a certain system of instruction does not mean that the instructor, though well respected by the former student, used the best method. The new instructor needs to continue to grow in his or her role of instructor, seeking other resources and information to enhance his or her own teaching skills. Standards of performance. An aviation instructor is responsible for training an applicant to acceptable standards in all subject matter areas, procedures, and maneuvers included in the tasks within each area of operation in the appropriate Practical Test Standard, PTS. It must be emphasized that the PTS book is a testing document, not a teaching document. Figure 7-2. When teaching a particular procedure, an instructor might be tempted to point out the consequences of doing it differently, perhaps telling the student that failure to perform the procedure as taught will court disaster. The instructor may believe this consequence approach is necessary to ensure the student commits the procedure to memory. But the stated reasons for performing the procedure a certain way must contribute to the learning situation to be effective. Emphasizing the positive. Aviation instructors have a tremendous influence on a student's perception of aviation. The way instructors conduct themselves, the attitudes they display, and the manner in which they develop instruction all contribute to the formation of either positive or negative impressions by students. The success of an aviation instructor depends greatly on his or her ability to present instruction in a manner that gives students a positive image of aviation. Figure 7-3. Chapter 1, Human Behavior, emphasizes that a negative self-concept inhibits the perceptual process, that fear adversely affects student perceptions, that the feeling of being threatened limits the ability to perceive, and that negative motivation is not as effective as positive motivation. Merely knowing about these factors is not enough. Instructors must be able to detect these factors in their students and strive to prevent negative feelings from undermining the instructional process. Consider how the following scenarios, conducted during the first lesson, might influence and impress a new student pilot who has limited or no aviation experience. An indoctrination in pre-flight procedures with emphasis on the critical precautions which must be taken before every flight because emergencies in flight can be caused by an improper pre-flight and are often disastrous. Instruction and hands-on training in the care that must be taken in taxiing an airplane because if you go too fast, you may lose directional control of the aircraft. Introduction and demonstration of stalls because this is how so many people lose their lives in airplanes. Illustrating and demonstrating forced landings during the first lesson because one should always be prepared to cope with a rope break in a glider. These new experiences might make the student wonder if learning to fly is a good idea. In contrast, consider a first lesson in which the pre-flight inspection is presented to familiarize the student with the aircraft and its components, and the flight is a perfectly normal one to a nearby airport with return. Following the flight, the instructor can call the student's attention to the ease with which the trip was made in comparison with other modes of transportation, and the fact that no critical incidents were encountered or expected. This does not mean stalls and emergency procedures should be omitted from training. It only illustrates the positive approach in which the student is not overwhelmed with information that he or she may not be prepared to digest. Again, this reinforces the need for the instructor to employ a syllabus which makes sense and consider student ability to comprehend new information. The introduction of emergency procedures after the student has developed an acquaintance with normal operations is not as likely to be discouraging and frightening, or to inhibit learning by the imposition of fear. There is nothing in aviation that demands that students must suffer as part of their instruction. Every effort should be made to ensure instruction is given under positive conditions that reinforce training conducted to standard and modification of the method of instruction when students have difficulty grasping a task. In essence, a student's failure to perform is viewed as an instructor's inability to transfer the information. Otherwise, the instructor fails to consider himself or herself as part of a broken learning chain. Emphasize the positive, because positive instruction results in positive learning. Minimizing student frustrations. Minimizing student frustrations in the classroom, shop, or during flight training is an instructor's responsibility. By following the basic rules, instructors can reduce student frustrations and create a learning environment that encourages rather than discourages learning. For example, lesson plans used as part of an organized curriculum help the student pilot measure training progress. Since most pilots don't want to be students, the ability to measure their progress or see an end in sight reduces frustration and increases pilot motivation. Figure 7-4. Motivate students. More can be gained from wanting to learn than from being forced to learn. Too often, students do not realize how a particular lesson or course can help them reach an important goal. When students can see the benefits and purpose of the lesson or course, their enjoyment and their efforts increase. Keep students informed. Students feel insecure when they do not know what is expected of them or what is going to happen to them. Instructors can minimize feelings of insecurity by telling students what is expected of them and what they can expect in return. Instructors keep students informed in various ways, including giving them an overview of the course, keeping them posted on their progress, and giving them adequate notice of examinations, assignments, or other requirements. Approach students as individuals. When instructors limit their thinking to the whole group without considering the individuals who make up that group, their efforts are directed at an average personality that really fits no one. Each group has its own personality that stems from the characteristics and interaction of its members. However, each individual within the group has a unique personality to be constantly considered. Give credit when due. When students do something extremely well, they normally expect their abilities and efforts to be noticed. Otherwise, they may become frustrated. Praise or credit from the instructor is usually ample reward and provides an incentive to do even better. Praise pays dividends in student effort and achievement when deserved, but when given too freely, it becomes valueless. Criticize constructively. Although it is important to give praise and credit when deserved, it is equally important to identify mistakes and failures. It does not help to tell students they have made errors and provide no explanations. If a student has made an earnest effort but is told that the work is unsatisfactory, with no other explanation, frustration occurs. Errors cannot be corrected if they are not identified, and if they are not identified, they will probably be perpetuated through faulty practice. On the other hand, if the student is briefed on the errors and is told how to correct them, progress can be made. Be consistent. Students want to please their instructor. This is the same desire that influences much of the behavior of subordinates toward their superiors in industry and business. Naturally, students have a keen interest in knowing what is required to please the instructor. If the same thing is acceptable one day and unacceptable the next, the student becomes confused. The instructor's philosophy and actions must be consistent. Admit errors. No one, including students, expects an instructor to be perfect. The instructor can win the respect of students by honestly acknowledging mistakes. If the instructor tries to cover up or bluff, students are quick to sense it. Such behavior tends to destroy student confidence in the instructor. If in doubt at some point, the instructor should admit it. Flight instructor responsibilities. Learning to fly should provide students with an opportunity for exploration and experimentation. It should be a habit-building period during which students devote their attention, memory, and judgment to the development of correct habit patterns. All aviation instructors shoulder an enormous responsibility because their students will ultimately be flying, servicing, or repairing aircraft. But flight instructors have the added responsibilities of evaluating student pilots and making a decision on whether they are ready to solo. The flight instructor's job is to mold the student pilot into a safe pilot who takes a professional approach to flying. Other flight instructor responsibilities can be found in Title 14 of the Code of Federal Regulations, 14 CFR, Part 61, and FAA Advisory Circulars, ACs, Figure 5-7. Figure 5-7 text. The flight instructor has many additional responsibilities: evaluation of student piloting ability, pilot supervision, practical test recommendations, flight instructor endorsements, additional training and endorsements, pilot proficiency, see and avoid responsibilities, students' pre-solo flight thought process. End of Figure 7-5. Flight instructors must provide the most comprehensive ground and flight instruction possible. They should be current and proficient in the aircraft they use for flight instruction, encouraging each pilot to learn as much as he or she can and to continually raise the bar. Flight instructors have the responsibility of producing the safest pilots possible with the overall focus on education and learning. It is also important to convey an understanding of why pilots are trained to standards and how they are set. Instructors should not introduce the minimum acceptable standards for passing the check ride when introducing lesson tasks. The minimum standards to pass the check ride should be introduced during the 3 hours of preparation for the check ride. Keep the PTS in the proper perspective, with emphasis on the practical test standard, PTS, increasing later in the training. Physiological obstacles for flight students. Although most student pilots have been exposed to air travel, they may not have flown in light training aircraft. Consequently, students may react to unfamiliar noises or vibrations, or experience unfamiliar sensations due to G-force or an uncomfortable feeling in the stomach. To teach effectively, instructors cannot ignore the existence of these negative factors, nor should they ridicule students who are adversely affected. These negative sensations can usually be overcome by understanding the nature of their causes. Remember, a sick student does not learn well. Ensuring student skill set. Flight instructors must ensure student pilots develop the required skill and knowledge prior to solo flight. The student pilot must show consistency in the required solo tasks, takeoff and landings, ability to prioritize in maintaining control of the aircraft, proper navigation skills, proficiency in flight, proper radio procedures and communication skills, and traffic pattern operation. Student pilots should receive instruction to ask for assistance or help from the ATC system when needed. Mastery of the skill set includes consistent use and continued growth, as well as increased accuracy of performance. The instructor determines when a student is ready for his or her first solo flight. Generally, this determination is made when the instructor observes the student from pre-flight to engine start to engine shutdown, and the student performs consistently without need of instructor assistance. Flight instructors need to provide adequate flight and ground instruction for special emphasis items listed in each PTS for airplane, helicopter, and light sport aircraft. The student needs to be knowledgeable in these special emphasis areas because examiners and authorized instructors place special emphasis upon areas considered critical to flight safety. Special emphasis items include, but are not limited to: 1. Positive aircraft control. 2. Procedures for positive exchange of flight controls. 3. Stall and spin awareness, if appropriate. 4. Collision avoidance. 5. Wake turbulence and low-level wind turbulence and wind shear avoidance. 6. Runway incursion avoidance. 7. Controlled flight into terrain, CFIT. 8. Aeronautical decision-making, ADM/risk management. 9. Checklist usage. 10. Spatial disorientation. 11. Temporary flight restrictions, TFR. 12. Special use airspace, SUA. 13. Aviation security. 14. Wire strike avoidance. Flight instructors should be current on the latest procedures regarding pilot training, certification, and safety. It is the flight instructor's responsibility to maintain a current library of information. These sources are listed in the appropriate PTS, and other sources can be located on the Internet at www.faa.gov and www.faasafety.gov. The FAA website provides comprehensive information to pilots and instructors. Other aviation instructions also have excellent information. However, an instructor is bound to follow any procedures in the manner prescribed by the FAA. If an instructor needs any assistance, he or she should contact a more experienced instructor, an FAA-designated pilot examiner, DPE, or the local Flight Standards District Office, FSDO. Aviator's Model Code of Conduct. The Aviator's Model Code of Conduct presents broad guidance and recommendations for general aviation, GA pilots to improve airmanship, flight safety, and to sustain and improve the GA community. The Code of Conduct presents a vision of excellence in GA aviation. Its principles both complement and supplement what is merely legal. The Code of Conduct is not a standard, and it is not intended to be implemented as such. The Code of Conduct consists of the following 7 sections. 1. General responsibilities of aviators. 2. Passengers and people on the surface. 3. Training and proficiency. 4. Security. 5. Environmental issues. 6. Use of technology. 7. Advancement and promotion of general aviation. Each section provides flight instructors a list of principles and sample recommended practices. Successful instructor pilots continue to self-evaluate and find ways to make themselves safer and more productive instructors. The Aviator's Model Code of Conduct provides guidance and principles for the instructor to integrate into their own practices. More information about the Aviator's Model Code of Conduct can be found at www.secureav.com. Safety Practices and Accident Prevention. Aviation instructors are the front line of efforts to improve the safety record of the aviation industry. Safety, one of the most fundamental considerations in aviation training, is paramount. FAA regulations intended to promote safety by eliminating or mitigating conditions that can cause death, injury, or damage are comprehensive, but even the strictest compliance with regulations may not be sufficient to guarantee safety. Rules and regulations are designed to address known or suspected conditions detrimental to safety, but there is always a chance that some new combination of circumstances, not contemplated by the regulations, will arise. It is important for aviation instructors to be proactive to ensure the safety of flight or maintenance training activities. The safety practices aviation instructors emphasize have a long-lasting effect on students. Generally, students consider their instructor to be a role model whose habits they attempt to imitate, whether consciously or unconsciously. The instructor's advocacy and description of safety practices mean little to a student if the instructor does not demonstrate them consistently. For example, a maintenance student observes the instructor violating safety practices by not wearing safety glasses around hazardous equipment. The student probably will not be conscientious about using safety equipment when the instructor is not around. One of the best actions a flight or maintenance instructor can take to enhance aviation safety is to emphasize safety by example. Another way for the instructor to advocate safety is to join the new FAA safety team, FAA-STEAM, FAST team. The FAST team is dedicated to improving the aviation safety record by conveying safety principles and practices through training, outreach, and education. More information is available at faasafety.gov. Professionalism. The aviation instructor is the central figure in aviation training and is responsible for all phases of required training. The instructor, either pilot or aircraft maintenance technician, must be professional. As professionals, aviation instructors strive to maintain the highest level of knowledge, training, and currency in the field of aviation. To achieve this goal, instructors need to commit themselves to continuous, lifelong learning and professional development through study, service, and membership in professional organizations such as the National Association of Flight Instructors, NAFI, and Professional Aviation Mechanics Association, PAMA. Professionals build a library of resources that keeps them in touch with their field through the most current procedures, publications, and educational opportunities. Being a professional also means behaving in a professional manner, Figure 7-6. An aviation instructor should strive to practice the characteristics on the instructor do list while teaching a student. Sincerity. The aviation instructor should be straightforward and honest. Attempting to hide inadequacy behind a smokescreen of unrelated instruction makes it impossible for the instructor to command the respect and full attention of a student. Teaching an aviation student is based upon acceptance of the instructor as a competent, qualified teacher and an expert pilot or aircraft maintenance technician. Any facade of instructor pretentiousness, whether it is real or mistakenly presumed by the student, causes the student to lose confidence in the instructor, and learning is adversely affected. Acceptance of the student. The instructor must accept students as they are, including all their faults and problems. The student is a person who wants to learn, and the instructor is a person who is available to help in the learning process. Beginning with this understanding, the professional relationship of the instructor with the student should be based on a mutual acknowledgement that the student and instructor are important to each other, and that both are working toward the same objective. Under no circumstance should the instructor do anything which implies degrading the student. Acceptance rather than ridicule and support rather than reproof encourage learning. Students must be treated with respect, regardless of whether they are quick to learn or require more time to absorb certain concepts. Criticizing a student who does not learn rapidly is similar to a doctor reprimanding a patient who does not get well as rapidly as predicted. Personal appearance and habits. Personal appearance has an important effect on the professional image of the instructor. Today's aviation customer expects an instructor to be neat, clean, and appropriately dressed. Since the instructor is engaged in a learning situation, the attire worn should be appropriate to professional status. Figure 7-7. Personal habits have a significant effect on the professional image. The exercise of common courtesy is perhaps the most important of these. An instructor who is rude, thoughtless, and inattentive cannot hold the respect of a student, regardless of the instructor's ability as a pilot or aviation maintenance technician. Personal cleanliness is important to aviation instruction. Frequently, an instructor and a student work in close proximity, and even little annoyances such as body odor or bad breath can cause serious distractions from learning the tasks at hand. Demeanor. The attitude and behavior of an instructor can contribute much to a professional image. The instructor should avoid erratic movements, distracting speech habits, and capricious changes in mood. The professional image requires development of a calm, thoughtful, and disciplined demeanor. The successful instructor avoids contradictory directions, reacting differently to similar or identical errors at different times, demanding unreasonable performance or progress, or criticizing a student unfairly and presenting an overbearing manner or air of flippancy. Effective instruction is best conducted in a calm, pleasant, and thoughtful manner that puts the student at ease. The instructor must constantly demonstrate competence in the subject matter and genuine interest in the student's well-being. Proper language. In aviation instruction, as in other professional activities, the use of profanity and obscene language leads to distrust or, at best, a lack of complete confidence in the instructor. Many people object to such language. The professional instructor speaks normally, without inhibitions, and speaks positively and descriptively without profanity. Evaluation of student ability. Evaluation of a student's ability is an important element of instruction. Used in this context, evaluation refers to judging a student's performance to perform a maneuver or procedure. Demonstrated ability. Evaluation of demonstrated ability during flight or maintenance instruction is based upon established standards of performance, suitably modified to apply to the student's experience and stage of development as a pilot or mechanic. The evaluation considers the student's mastery of the elements involved in the maneuver or procedure rather than merely the overall performance. For example, qualification of student pilots for solo and solo cross-country privileges depend upon demonstrations of performance. Keeping the student informed. In evaluating student demonstrations of ability, it is important for the aviation instructor to keep the student informed of progress. This may be done as each procedure or maneuver is completed or summarized during a post-flight or class critique. These critiques should be in a written format, such as notes, to aid the instructor in covering all areas that were noticed during the flight or lesson. When explaining errors in performance, instructors point out the elements in which the deficiencies are believed to have originated and, if possible, suggest appropriate corrective measures. Correction of student errors. Correction of student errors does not include the practice of taking over from students immediately when a mistake is made. Safety permitting, it is frequently better to let students progress part of the way into the mistake and find a way out. For example, in a weight shift control aircraft, the bar is moved right to turn left. A student may show an initial tendency to move the bar in the direction of the desired turn. This tendency dissipates with time, but allowing the student to see the effect of his or her control input is a valuable aid in illustrating the stability of the aircraft. It is difficult for students to learn a maneuver properly if they seldom have the opportunity to correct an error. On the other hand, students may perform a procedure or maneuver correctly, but not fully understand the principles and objectives involved. If the instructor suspects this, students should be required to vary the performance of the maneuver or procedure slightly. The maneuver or procedure may be combined with other operations, or the same elements should be applied to the performance of other maneuvers or procedures. Students who do not understand the principles involved will probably not be able to successfully complete the revised maneuver or procedure. Aviation instructors and exams. Knowledge test. When preparing a student or applicant for the private pilot certification or higher grade, i.e., commercial or instrument, a test is required to ensure the student has adequate aeronautical knowledge in those subject areas listed in 14 CFR Part 61. The instructor may provide the student with an endorsement to certify he or she has the required knowledge to pass the test. Some additional ratings do not require a test. For information concerning additional aircraft certifications that do not require knowledge tests, refer to AC 61-65, Certification, Pilots and Flight Ground Instructors. Flight instructors must take a short test for each additional category. An instructor should remember he or she is held accountable for deficient instructional performance. This is important for any instructor who signs recommendations for applicants who were not trained by that instructor. If the applicant fails a test, the aviation instructor must sign the test after he or she has provided additional training in the areas the applicant failed. The applicant is given a retest. Prior to certification, the aviation instructor must make a statement that he or she gave the required training in the preceding 60 days, and the instructor reviewed those areas of deficiency on the applicant's knowledge test. Practical test. Provision is made on the Airman Certificate or Rating Application Form for the written recommendation of the flight instructor who has prepared the applicant for the practical test involved. Signing this recommendation imposes a serious responsibility on the flight instructor. A flight instructor who makes a practical test recommendation for an applicant seeking a certificate or rating should require the applicant to thoroughly demonstrate the knowledge and skill level required for that certificate or rating. This demonstration should in no instance be less than the complete procedure prescribed in the applicable PTS. When the instructor endorses the applicant for the practical test, his or her signature on the FAA Form 8710-1, Airman Certificate and/or Rating Application, is valid for 60 days. This is also true with the flight proficiency endorsement that is placed in the applicant's log or training record, AC 61-65. These two dates should be the same. Completion of prerequisites for a practical test is another instructor task that must be documented properly. Examples of all common endorsements can be found in the current issue of AC 61-65, Appendix 1. This appendix includes reference to 14 CFR Part 61 for more details concerning the requirements that must be met to qualify for each respective endorsement. The examples shown contain the essential elements of each endorsement. It is not necessary for all endorsements to be worded exactly as those in the AC. For example, changes to regulatory requirements may affect the wording, or the instructor may customize the endorsement for any special circumstances of the applicant. However, at a minimum, the instructor needs to cite the appropriate 14 CFR Part 61 section that has been completed. If a flight instructor fails to ensure a student pilot or additional rating pilot meets the requirements of regulations prior to making endorsements to allow solo flight or additional rating, that instructor is exhibiting a serious deficiency in performance. The FAA holds him or her accountable. Providing a solo endorsement for a student pilot who is not proficient for solo flight operations, or providing an endorsement for an additional rating for a pilot not meeting the appropriate regulatory requirements, is also a breach of faith with the student or applicant. Professional development. Aviation is changing rapidly, and aviation instructors must continue to develop their knowledge and skills in order to teach successfully in this environment. The aviation instructor is well respected by other technicians and pilots because instructors must meet additional training requirements in order to be certificated. Flight instructors undergo comprehensive evaluation and a practical test to obtain a flight instructor certificate. 14 CFR Part 147 requires all instructors teaching maintenance subjects to hold an FAA certificate as an aircraft maintenance technician. Successful professional aviation instructors do not become complacent or satisfied with their own qualifications and abilities, and are constantly alert for ways to improve their qualifications, effectiveness, and the services they provide to students. Considered by their students to be a source of up-to-date information, instructors have the opportunity and responsibility of introducing new procedures and techniques both to their students and to other aviation professionals with whom they come in contact. Continuing education. A professional aviation instructor continually updates his or her knowledge and skills. This goal is attained in a variety of ways, such as reading an article in a technical publication or taking a course at a technical school. There are many different sources of information the aviation instructor can use in order to remain current in aviation knowledge and teaching. Government. One of the first educational sources for the instructor is the FAA and other governmental agencies. The FAA either sponsors or collaborates in sponsoring aviation programs, seminars, and workshops for the public. For example, the FAA conducts safety seminars around the country in conjunction with the aviation industry. These seminars, although directed at pilots, can be a useful source of knowledge for aviation instructors. The FAA is a rich source of information that can be used to enhance an instructor's knowledge. Regulations, advisory circulars, airworthiness directives, orders, and notices are some of the documents that can be downloaded from the FAA website at www.faa.gov. As mentioned earlier in the chapter, participation in the Pilot Proficiency Awards program is a good way for a flight instructor to improve proficiency and to serve as an example to students. Another way is to work toward the Gold Seal Flight Instructor Certificate. Accomplishing the requirements of the certificate is evidence the instructor has performed at a very high level as a flight instructor. See AC 61-65, Certification, Pilots and Flight and Ground Instructors, for a list of requirements for earning this certificate. Similarly, the Aviation Maintenance Awards program affords the aviation maintenance instructor the opportunity for increased education through attendance at FAA or industry maintenance training seminars. Details for the awarding of the bronze through diamond pins can be found in AC 65-25, Aviation Maintenance Technician Awards Program. The FAA approves the sponsors who conduct Flight Instructor Refresher Clinics, FIRCs, in accordance with AC 61-83. Nationally, the FAA approved industry-conducted Flight Instructor Refresher Clinics, FIRC. These courses are available for flight instructors to complete the training requirements for renewal of flight instructor certificates. The FAA co-sponsors Inspection Authorization, IA, seminars. These seminars are open to all maintenance technicians and are a good source of additional training and education for maintenance instructors. Educational/training institutions. Professional aviation instructors can further increase their knowledge and skill in aviation specialties by attending classes at local community colleges, technical schools, or universities. These schools may offer complete degree programs in aviation subjects, as well as single subject courses of benefit to instructors. Commercial organizations. Commercial organizations are another important source of education/training for the aviation instructor. Some may be publishers of training materials, while others may provide complete ground and flight training programs for professional pilots and instructors. These companies often provide a wide variety of study programs, computer-based training, and printed publications. Many offer training that can be attended either at the home base of the company or in traveling classes/seminars, so instructors can more easily attend. There are numerous organizations around the country that offer courses of training for aviation instructors. These are generally courses that are available to all pilots and technicians, but are especially useful for instructors to improve their abilities. Examples of such courses include workshops for maintenance technicians to enhance their skills in subjects such as composites, sheet metal fabrication, and fabric covering. For pilots, there are courses in mountain flying, spin training, and tailwheel qualification. Flight instructors also may increase their aviation knowledge and experience by adding additional category and class ratings to their certificates. Industry organizations. Other significant sources of ongoing education for aviation instructors are aviation organizations. These organizations not only provide educational articles in their publications, but also present training programs or co-sponsor such programs. Many industry organizations have local affiliated chapters that make it easy to meet other pilots, technicians, and instructors. These meetings frequently include presentations by industry experts as well as formal training sessions. Some aviation industry organizations conduct their own training sessions on areas such as flight instructor refresher clinics and inspection authorization IA seminars. Properly organized safety symposiums and training clinics are valuable sources of refresher training. They are also an excellent opportunity to exchange information with other instructors. Sources of material. An aviation instructor should maintain access to current flight publications or maintenance publications. For the flight instructor, this includes current copies of regulations pertinent to pilot qualification and certification, Aeronautical Information Manual, AIM, Appropriate Practical Test Standards, PTS, and pilot training manuals. The aviation maintenance instructor should have copies of applicable regulations, current knowledge and PTS, and maintenance training manuals. Aviation instructors must be thoroughly familiar with current certification and rating requirements in order to provide competent instruction. AC 00.2-15, Advisory Circular Checklist, is a listing of all current advisory circulars and other FAA publications sold by the Superintendent of Documents, U.S. Government Printing Office, GPO, or available online at www.faa.gov. Many of the advisory circulars should be considered by the aviation instructor for inclusion in a personal reference library. In addition to government publications, a number of excellent handbooks and other reference materials are available from commercial publishers. Aviation periodicals and technical journals from the aviation industry are other sources of valuable information for instructors. Many public and institutional libraries have excellent resource material on educational psychology, teaching methods, testing, and other aviation-related subjects. The aviation instructor has two reasons to maintain a source of current information and publications. First, the instructor needs a steady supply of fresh material to make instruction interesting and up-to-date. Second, instructors should keep themselves well informed by maintaining familiarity with what is being written in current aviation publications. Most of these publications are in printed form, but increasingly information is available through electronic means. Figure 7-8. Printed material. In aviation, documentation in the form of flight publications or maintenance data must be immediately available for referral while flying or conducting maintenance. While the portability of printed materials meets this need for immediate availability, printed material has two disadvantages. First, it takes up space for storage, and second, it can be time-consuming to keep printed material current. Many publishers of printed material now make their information available in electronic format. For example, most FAA regulations, standards, and guides are available either in electronic format or as hard copy. Non-FAA publications are available through the GPO and from the National Technical Information Service, NTIS. Publications not printed by the U.S. Government Printing Office are available from many publishers and suppliers of books. Commercial publishers usually provide catalogs and toll-free numbers or websites for ordering their products. Electronic sources. Access to the Internet via personal computer has opened up a vast storehouse of information for the aviation instructor. In the past, aviation instructors had limited access to information, but the personal computer has greatly expanded sources of aviation information. This section lists some sources of information on the Internet. In the following discussion, several sites for accessing FAA materials are explored, and some non-FAA sites are included. Once instructors begin to navigate the Internet, they find sites which provide the information they use most frequently. Obviously, some FAA publications are more important to the aviation instructor than others. Many of the publications of interest to the aviation instructor can be accessed through the FAA website, www.faa.gov. The FAA website is not the only source of aviation or education-related information on the Internet. The aviation instructor can access aviation-related publications at other government or non-government websites via published web addresses or by using the search function of the web browser. Keep in mind that most sites on the Internet are updated periodically, but some are not. In addition, new sites are added and old sites are discontinued on a regular basis. The aviation instructor can become more adept at obtaining information by entering and navigating around the Internet to become informed about the contents and how to best locate desired information. The more familiar aviation instructors become with the Internet, the better they are able to adapt to any changes that may occur. Professional aviation instructors must continue to expand their knowledge and skills in order to become competent instructors. The field of aviation is advancing, and the instructor also must advance. Instructors can best do this by taking advantage of the wide variety of materials available from the FAA, other government agencies, commercial publishers and vendors, and from industry trade groups. These materials are available at training sessions and seminars, from printed books, papers, magazines, and from the Internet and other electronic sources. Instructors who are committed to continuing education are able to provide the highest quality instruction to their students. Chapter Summary. This chapter discussed the responsibilities of aviation instructors to the student, the public, and the FAA in the training process. The additional responsibilities of flight instructors who teach new student pilots, as well as rated pilots seeking add-on certification, the role of aviation instructors as safety advocates, and ways in which aviation instructors can enhance their professional image and development were explored. End of Chapter 7. Chapter 8 of Aviation Instructor's Handbook by the FAA. This LibriVox recording is in the public domain. Chapter 8. Techniques of Flight Instruction. Introduction. Certificated Flight Instructor, CFI, Daniel, decides his student Mary has gained enough confidence in flying that it is time for her to develop personal weather minimums. While researching the subject at the Federal Aviation Administration, FAA, website, he locates several sources that provide background information, such as the fact that, statistically, weather often poses some of the greatest risks to general aviation GA pilots, regardless of their experience level. He also finds charts and a lesson plan he can use. Daniel's decision to help Mary develop personal weather minimums reflects a key component of the flight instructor's job, providing the student with the tools to ensure safety during a flight. Every flight instructor can agree that everyone wants to be safe, but what does safety really mean? How can a flight instructor ensure the safety of flight training activities and also train clients to operate their aircraft safely after they leave the relatively protected flight training environment? According to one definition, safety is the freedom from conditions that can cause death, injury, or illness, damage to or loss of equipment or property, or damage to the environment. FAA regulations are intended to promote safety by eliminating or mitigating conditions that can cause death, injury, or damage. These regulations are comprehensive, but there has been increasing recognition that even the strictest compliance with regulations may not be sufficient to guarantee safety. Rules and regulations are designed to address known or suspected conditions detrimental to safety, but there is always the probability that some new combination of circumstances, not contemplated by the regulations, will arise. The recognition of aviation training and flight operations has led to a system approach to aviation safety. Since flight instructors are a critical part of the aviation safety system, this chapter introduces system safety, aeronautical decision-making, ADM, risk management, situational awareness, and single pilot resource management, SRM, in the modern flight training environment. It also provides methods flight instructors can teach students to use practical risk management tools and discusses how to evaluate student decision-making. The chapter begins with practical strategies flight instructors can use to enhance their instruction, the demonstration performance training delivery method of flight instruction, integrated flight instruction, positive exchange of flight controls, use of distractions, obstacles to learning encountered during flight training, and how to evaluate students. After an intensive look at ADM, it closes with a discussion of CFI recommendations and endorsements. Flight instructor qualifications. A CFI must be thoroughly familiar with the functions, characteristics, and proper use of all flight instruments, avionics, and other aircraft systems being used for training. This is especially important due to the wide variety of global positioning system, GPS, and glass panel displays. It is the personal responsibility of each flight instructor to maintain familiarity with current pilot training techniques and certification requirements. This may be done by frequent review of new periodicals and technical publications, personal contacts with FAA inspectors and designated pilot examiners, DPE, and by participation in pilot and flight instructor clinics. Additional information can be obtained from veteran flight instructors, Figure 8-1. The application of outmoded instructional procedures or the preparation of students using obsolete certification requirements is inexcusable. Practical flight instructor strategies. During all phases of flight training, CFIs should remember they are role models for the student. The flight instructor should demonstrate good aviation sense at all times. Before the flight, discuss safety and importance of proper pre-flight and use of the checklist. During flight, prioritize the tasks of aviating, navigating, and communicating. Instill importance of see and avoid in the student. During landing, conduct stabilized approaches. Maintain desired airspeed on final. Demonstrate good judgment for go-arounds, wake turbulence, traffic, and terrain avoidance. Use ADM to correct faulty approaches and landing errors. Make power off, stall warning blaring, on centerline touchdowns in the first third of runway. Always remember safety is paramount. Flight instructors have the responsibility of producing the safest pilots possible. For that reason, CFIs should encourage each student to learn as much as he or she is capable of and keep raising the bar. When introducing lesson tasks, flight instructors should not introduce the minimum acceptable standards for passing the check ride. The Practical Test Standard, PTS, is not a teaching tool. It is a testing tool. The overall focus of flight training should be on education, learning, and understanding why the standards are there and how they were set. The minimum standards to pass the check ride should not be introduced until the 3 hours of preparation for the check ride. Obstacles to learning during flight instruction. Certain obstacles are common to flight instruction and may apply directly to the student's attitude, physical condition, and psychological makeup. These include, but are not limited to, feeling of unfair treatment, impatience to proceed to more interesting operations, worry or lack of interest, physical discomfort, illness, fatigue, and dehydration, apathy due to inadequate instruction, anxiety, unfair treatment. Students who believe their instruction is inadequate or that their efforts are not conscientiously considered and evaluated do not learn well. In addition, their motivation suffers, no matter how intent they are on learning to fly. Motivation also declines when a student believes the instructor is making unreasonable demands for performance and progress. Figure 8-2. Assignment of goals the student considers difficult but possible usually provides a challenge and promotes learning. In a typical flight lesson, reasonable goals are listed in the lesson objectives, and the desired levels of proficiency for the goals are included in statements that contain completion standards. Impatience. Impatience is a greater deterrent to learning pilot skills than is generally recognized. For a student, this may take the form of a desire to make an early solo flight or to set out on cross-country flights before the basic elements of flight have been learned. The impatient student fails to understand the need for preliminary training and seeks only the ultimate objective without considering the means necessary to reach it. With every complex human endeavor, it is necessary to master the basics if the whole task is to be performed competently and safely. The instructor can correct student impatience by presenting the necessary preliminary training one step at a time, with clearly stated goals for each step. The procedures and elements mastered in each step should be clearly identified in explaining or demonstrating the performance of the subsequent step. Impatience can result from instruction keyed to the pace of a slow learner when it is applied to a motivated, fast learner. It is just as important that a student be advanced to the subsequent step as soon as one goal has been attained, as it is to complete each step before the next one is undertaken. Disinterest grows rapidly when unnecessary repetition and drill are requested on operations that have already been adequately learned. Worry or lack of interest. Worry or lack of interest has a detrimental effect on learning. Students who are worried or emotionally upset are not ready to learn and derive little benefit from instruction. Worry or distraction may be due to student concerns about progress in the training course, or may stem from circumstances completely unrelated to their instruction. Significant emotional upsets may be due to personal problems, psychiatric disturbances, or a dislike of the training program or the instructor. The experiences of students outside their training activities affect behavior and performance in training. The two cannot be separated. When students begin flight training, they bring with them their interests, enthusiasms, fears, and troubles. The instructor cannot be responsible for these outside diversions, but cannot ignore them because they have a critical effect on the learning process. Instruction must be keyed on the utilization of the interests and enthusiasm students bring with them, and to diverting their attention from their worries and troubles to learning the task at hand. This is admittedly difficult, but must be accomplished if learning is to proceed at a normal rate. Worries and emotional upsets that result from a flight training course can be identified and addressed. These problems are often due to inadequacies of the course or of the instructor. The most effective cure is prevention. The instructor must be alert and ensure students understand the objectives of each step of their training, and that they know at the completion of each lesson exactly how well they have progressed and what deficiencies are apparent. Discouragement and emotional upsets are rare when students feel that nothing is being withheld from them or is being neglected in their training. Physical discomfort, illness, fatigue, and dehydration. Physical discomfort, illness, and fatigue will materially slow the rate of learning during both classroom instruction and flight training. Students who are not completely at ease and whose attention is diverted by discomforts such as the extremes of temperature, poor ventilation, inadequate lighting, or noise and confusion cannot learn at a normal rate. This is true no matter how diligently they attempt to apply themselves to the learning task. A minor illness, such as a cold, major illness, or injury, interferes with the normal rate of training. This is especially important for flight instruction. Most illnesses adversely affect the acuteness of vision, hearing, and feeling, all of which are essential to correct performance. Air sickness can be a great deterrent to flight instruction. A student who is airsick or bothered with incipient air sickness is incapable of learning at a normal rate. There is no sure cure for air sickness, but resistance or immunity usually can be developed in a relatively short period of time. An instructional flight should be terminated as soon as an incipient illness is experienced. As the student develops immunity, flights can be increased in length until normal flight periods are practicable. Keeping students interested and occupied during flight is a deterrent to airsickness. They are much less apt to become airsick while operating the controls themselves. Rough air and unexpected abrupt maneuvers tend to increase the chances of airsickness. Tension and apprehension apparently contribute to airsickness and should be avoided. Fatigue. Fatigue is one of the most treacherous hazards to flight safety, as it may not be apparent to a pilot until serious errors are made. Fatigue can be either acute, short-term, or chronic, long-term. Acute fatigue, a normal occurrence of everyday living, is the tiredness felt after long periods of physical and mental strain, including strenuous muscular effort, immobility, heavy mental workout, strong emotional pressure, monotony, and lack of sleep. Acute fatigue, caused by training operations, may be physical or mental or both. It is not necessarily a function of physical robustness or mental acuity. The amount of training any student can absorb without incurring debilitating fatigue varies. Generally speaking, complex operations tend to induce fatigue more rapidly than simpler procedures do, regardless of the physical effort involved. Fatigue is the primary consideration in determining the length and frequency of flight instruction periods, and flight instruction should be continued only as long as the student is alert, receptive to instruction, and is performing at a level consistent with experience. It is important for a CFI to be able to detect fatigue both in assessing a student's substandard performance early in a lesson and also in recognizing the deterioration of performance. If fatigue occurs as a result of application to a learning task, the student should be given a break in instruction and practice. A CFI who is familiar with the signs indicative to acute fatigue will be more aware if the student is experiencing them. The deficiencies listed below are apparent to others before the individual notices any physical signs of fatigue. Acute fatigue is characterized by inattention, distractibility, errors in timing, neglect of secondary tasks, loss of accuracy and control, lack of awareness of error accumulation, irritability. Another form of fatigue is chronic fatigue, which occurs when there is not enough time for full recovery from repeated episodes of acute fatigue. Chronic fatigue's underlying cause is generally not rest-related and may have deeper points of origin. Therefore, rest alone may not resolve chronic fatigue. Chronic fatigue is a combination of both physiological problems and psychological issues. Psychological problems, such as financial, home life, or job-related stresses, cause a lack of qualified rest that is only solved by mitigating the underlying problems before the fatigue is solved. Without resolution, human performance continues to fall off and judgment becomes impaired so that unwarranted risks may be taken. Recovery from chronic fatigue requires a prolonged and deliberate solution. In either case, unless adequate precautions are taken, personal performance could be impaired and adversely affect pilot judgment and decision-making. Dehydration and heat stroke. Dehydration is the term given to critical loss of water from the body. Dehydration reduces a pilot's level of alertness, producing a subsequent slowing of decision-making processes or even the inability to control the aircraft. The first noticeable effect of dehydration is fatigue, which in turn makes top physical and mental performance difficult, if not impossible. Flying for long periods in hot summer temperatures or at high altitudes increases susceptibility to dehydration, since dry air at high altitudes tends to increase the rate of water loss from the body. If this fluid is not replaced, fatigue progresses to dizziness, weakness, nausea, tingling of hands and feet, abdominal cramps, and extreme thirst. Heat stroke is a condition caused by any inability of the body to control its temperature. Onset of this condition may be recognized by the symptoms of dehydration, but also has been known to be recognized only by complete collapse. To prevent these symptoms, it is recommended that an ample supply of water be carried and used at frequent intervals on any long flight, whether the pilot is thirsty or not. If the airplane has a canopy or roof window, wearing light-colored, porous clothing and a hat helps provide protection from the sun. Keeping the flight deck well ventilated aids in dissipating excess heat. Apathy due to inadequate instruction. Students can become apathetic when they recognize that the instructor has made inadequate preparations for the instruction being given, or when the instruction appears to be deficient, contradictory, or insincere. To hold the student's interest and to maintain the motivation necessary for efficient learning, well-planned, appropriate, and accurate instruction must be provided. Nothing destroys a student's interest as quickly as poorly organized period of instruction. Even an inexperienced student realizes immediately when the instructor has failed to prepare for a lesson. Figure 8-3. Instruction may be overly explicit and so elementary it fails to hold student interest, or it may be so general or complicated that it fails to evoke the interest necessary for effective learning. To be effective, the instructor must teach for the level of the student. The presentation must be adjusted to be meaningful to the person for whom it is intended. For example, instruction in the pre-flight inspection of an aircraft should be presented quite differently for a student who is a skilled aircraft maintenance technician, AMT, compared to the instruction on the same operation for a student with no previous aeronautical experience. The instruction needed in each case is the same, but a presentation meaningful to one of these students might not be appropriate for the other. Poor instructional presentations may result not only from poor preparation, but also from distracting mannerisms, personal untidiness, or the appearance of irritation with the student. Creating the impression of talking down to the student is one of the fastest ways for an instructor to lose student confidence and attention. Once the instructor loses student confidence, it is difficult to regain, and the learning rate is unnecessarily diminished. Anxiety. Student anxiety may place additional burdens on the instructor. This frequently limits the student's perceptive ability and retards the development of insights. The student must be comfortable, confident in the instructor and the aircraft, and at ease if effective learning is to occur. Providing this atmosphere for learning is one of the first and most important tasks of the instructor. Although doing so may be difficult at first, successive accomplishment of recognizable goals and avoidance of alarming occurrences or situations will rapidly ease the student's mind. This is true of all flight students, but special handling by the instructor may be required for students who are obviously anxious or uncomfortable. Demonstration Performance Training Delivery Method. The Demonstration Performance Training Delivery Method was discussed briefly in Chapter 4, The Teaching Process, but the following in-depth discussion is geared to the flight instructor. This training method has been in use for a long time and is very effective in teaching kinesthetic skills, so flight instructors find it valuable in teaching procedures and maneuvers. The Demonstration Performance Method is divided into 4 phases: explanation, demonstration, student performance with instructor supervision, and evaluation. Figure 8-4. Explanation phase. The flight instructor needs to be well prepared and highly organized if complex maneuvers and procedures are to be taught effectively. The student must be intellectually and psychologically ready for the learning activity. The explanation phase is accomplished prior to the flight lesson with a discussion of lesson objectives and completion standards, as well as a thorough pre-flight briefing. Explanations must be clear, pertinent to the objectives of the particular lesson to be presented, and based on the known experience and knowledge of the students. Students need to know not only what they will learn, but also how they will learn it. That is, how the lesson will proceed and how they will be evaluated. In teaching a skill, the instructor must convey to the students the precise actions they are to perform. In addition to the necessary steps, the instructor should describe the end result of these efforts. The explanation phase also should include coverage of appropriate safety procedures. Before leaving this phase, the instructor should encourage students to ask questions about any step of the procedure that they do not understand. Demonstration phase. The instructor must show students the actions necessary to perform a skill. As little extraneous activity as possible should be included in the demonstration if students are to clearly understand that the instructor is accurately performing the actions previously explained. If, due to some unanticipated circumstances, the demonstration does not closely conform to the explanation, this deviation should be immediately acknowledged and explained. Student performance and instructor supervision phases. As discussed in Chapter 4, these two phases involve separate actions that are performed concurrently. The first of these phases is the student's performance of the physical or mental skills that have been explained and demonstrated. The second activity is the instructor's supervision. Student performance requires students to act and do. To learn skills, students must practice. The instructor must, therefore, allot enough time for meaningful student activity. Through doing, students learn to follow correct procedures and to reach established standards. It is important that students be given an opportunity to perform the skill as soon as possible after a demonstration. Then, the instructor reviews what has been covered during the instructional flight and determines to what extent the student has met the objectives outlined during the pre-flight discussion. The instructor should be satisfied that the student is well prepared and understands the task before starting. The instructor observes as the student performs and then makes appropriate comments. Evaluation phase. In this phase, the instructor traditionally evaluates student performance, records the student's performance, and verbally advises the student of the progress made toward the objectives. Regardless of how well a skill is taught, there may still be performance deficiencies. When pointing out areas that need improvement, offer concrete suggestions that help. If possible, avoid ending the evaluation on a negative note. As discussed in Chapter 5, assessment, collaborative assessment, or learner-centered grading, LCG, is a form of authentic assessment currently used in aviation training with problem-based learning, PBL. PBL structures the lessons to confront the students with problems that are encountered in real life and forces them to reach real-world solutions. Scenario-based training, SBT, a type of PBL, uses a highly structured script of real-world experiences to address aviation training objectives in an operational environment. Collaborative assessment is used to evaluate whether certain learning criteria were met during the SBT. Collaborative assessment includes two parts: learner self-assessment and a detailed assessment by the flight instructor. The purpose of the self-assessment is to stimulate growth in the learner's thought processes and, in turn, behaviors. The self-assessment is followed by an in-depth discussion between the instructor and the student, which compares the instructor's assessment to the student's self-assessment. The telling and doing technique. The demonstration performance method can be applied to the telling and doing technique of flight instruction in 3 steps. However, the telling and doing technique includes specific variations for flight instruction. Figure 8-5. Instructor tells, instructor does. First, the flight instructor gives a carefully planned demonstration of the procedure or maneuver with accompanying verbal explanation. While demonstrating in-flight maneuvers, the instructor should explain the required power settings, aircraft attitudes, and describe any other pertinent factors that may apply. This is the only step in which the student plays a passive role. It is important for the demonstration to conform to the explanation as closely as possible. In addition, it should be demonstrated in the same sequence in which it was explained, so as to avoid confusion and provide reinforcement. Since students generally imitate the instructor's performance, the instructor must demonstrate the skill exactly the way the students are expected to practice it, including all safety procedures that the students must follow. If, due to some unanticipated circumstances, the demonstration does not closely conform to the explanation, this deviation should be immediately acknowledged and explained. Most physical skills lend themselves to a sequential pattern where the skill is explained in the same step-by-step order normally used to perform it. When the skill being taught is related to previously learned procedures or maneuvers, the known to unknown strategy may be used effectively. When teaching more than one skill at a time, the simple to complex strategy works well. By starting with the simplest skill, the student gains confidence and is less likely to become frustrated when faced with building skills that are more complex.
Another consideration in this phase is the language used. Instructors should attempt to avoid unnecessary jargon and technical terms that their students do not know. Instructors should also take care to clearly describe the actions students are expected to perform. Communication is the key. It is neither appropriate nor effective for instructors to try to impress students with their expertise by using language that is unnecessarily complicated. As an example, a level turn might be demonstrated and described by the instructor in the following way. Use outside visual references and monitor the flight instruments. After clearing the airspace around the aircraft, add power slightly, turn the aircraft to the desired direction, and apply a slight amount of back pressure on the yoke to maintain altitude. Maintain coordinated flight by applying the rudder in the direction of the turn. Remember, the ailerons control the roll rate as well as the angle of bank. The rate at which the aircraft rolls depends on how much aileron deflection is used. How far the aircraft rolls, steepness of the bank, depends on how long the ailerons are deflected, since the aircraft continues to roll as long as the ailerons are deflected. When the desired angle of bank is reached, neutralize the ailerons and trim as appropriate. Lead the rollout by approximately 1/2 the number of degrees of the angle of bank. Use coordinated aileron and rudder control pressures. Simultaneously begin releasing the back pressure so aileron, rudder, and elevator pressures are neutralized when the aircraft reaches the wings level position. Leading the rollout heading by 1/2 the bank angle is a good rule of thumb for initial training. However, keep in mind that the required amount of lead really depends on the type of turn rate, and rollout rate. As a pilot gains experience, he or she will develop a consistent roll-in and roll-out technique for various types of turns. Upon reaching a wings level attitude, reduce power and trim to remove control pressures. Student tells, instructor does. Second, the student tells as the instructor does. In this step, the student actually plays the role of instructor, telling the instructor what to do and how to do it. Two benefits accrue from this step. The student, being freed from the need to concentrate on performance of the maneuver and from concern about its outcome, is able to organize his or her thoughts regarding the steps involved and the techniques to be used. In the process of explaining the maneuver as the instructor performs it, perceptions begin to develop into insights. Mental habits begin to form with repetition of the instructions previously received. Plus, the instructor is able to evaluate the student's understanding of the factors involved in performance of the maneuver. According to the principle of primacy, it is important for the instructor to make sure the student gets it right the first time. The student should also understand the correct sequence and be aware of safety precautions for each procedure or maneuver. If a misunderstanding exists, it can be corrected before the student becomes absorbed in controlling the aircraft. Student tells, student does. Application is the third step of this method. This is where learning takes place and where performance habits are formed. If the student has been adequately prepared and the procedure or maneuver fully explained and demonstrated, meaningful learning occurs. The instructor should be alert during the student's practice to detect any errors in technique and to prevent the formation of faulty habits. At the same time, the student should be encouraged to think about what to do during the performance of a maneuver until it becomes habitual. In this step, the thinking can be done verbally. This focuses concentration on the task to be accomplished, so the total involvement in the maneuver is fostered. All of the student's physical and mental faculties are brought into play. The instructor should be aware of the student's thought processes. It is easy to determine whether an error is induced by a misconception or by a simple lack of motor skills. Therefore, in addition to forcing total concentration on the part of the student, this method provides a means for keeping the instructor aware of what the student is thinking. The student is not only learning to do something, but he or she is also learning a self-teaching process that is highly desirable in development of a skill. The exact procedures that the instructor should use during student practice depends on factors such as the student's proficiency level, the type of maneuver, and the stage of training. The instructor must exercise good judgment to decide how much control to use. With potentially hazardous or difficult maneuvers,
The instructor should be alert and ready to take control at any time. This is especially true during a student's first attempt at a particular maneuver. On the other hand, if a student is progressing normally, the instructor should avoid unnecessary interruptions or too much assistance. A typical test of how much control is needed often occurs during a student's first few attempts to land an aircraft. The instructor must quickly evaluate the student's need for help and not hesitate to take control if required. At the same time, the student should be allowed to practice the entire maneuver often enough to achieve the level of proficiency established in the lesson objectives. Since this is a learning phase rather than an evaluation phase of the training, errors or unsafe practices should be identified and corrected in a positive and timely way. In some cases, the student is not able to meet the proficiency level specified in the lesson objectives within the allotted time. When this occurs, the instructor should be prepared to schedule additional training. Positive exchange of flight controls. Positive exchange of flight controls is an integral part of flight training. It is especially critical during the demonstration performance method of flight instruction. Due to the importance of this subject, the following discussion provides guidance on the recommended procedure to use with a positive exchange of flight controls between pilots when operating an aircraft. Background: Incident/accident statistics indicate a need to place additional emphasis on the exchange of control of an airplane by pilots. Numerous accidents have occurred due to a lack of communication or misunderstanding regarding who had actual control of the aircraft, particularly between students and flight instructors. Establishing the following procedure during initial training will ensure the formation of a habit pattern that should stay with students throughout their flying careers. Procedure: During flight training, there must always be a clear understanding between students and flight instructors about who has control of the aircraft. The pre-flight briefing should include procedures for the exchange of flight controls. A positive three-step process in the exchange of flight controls between pilots is a proven procedure and one that is strongly recommended. When an instructor is teaching a maneuver to a student, the instructor normally demonstrates the maneuver first, then has the student follow along on the controls during a demonstration, and, finally, the student performs the maneuver with the instructor following along on the controls. Figure 8-6. Figure 8-6 text. During this procedure, a visual check is recommended to see that the other person actually has the flight controls. When returning the controls to the instructor, the student should follow the same procedure the instructor used when giving the control to the student. The student should stay on the controls and keep flying the aircraft until the instructor says, "I have the controls." There should never be any doubt about who is flying the aircraft. Positive exchange of flight controls. 1. When the instructor wishes the student to take control of the aircraft, the instructor says to the student, "You have the flight controls." 2. The student acknowledges immediately by saying, "I have the flight controls." 3. The flight instructor again says, "You have the flight controls." End of Figure 8-6. Flight instructors should always guard the controls and be prepared to take control of the aircraft. When necessary, the instructor should take the controls and calmly announce, "I have the flight controls." If an instructor allows a student to remain on the controls, the instructor may not have full and effective control of the aircraft. Anxious students can be incredibly strong and usually exhibit reactions inappropriate to the situation. If a recovery is necessary, there is absolutely nothing to be gained by having the student on the controls and having to fight for control of the aircraft. Students should never be allowed to exceed the flight instructor's limits. Flight instructors should not exceed their own ability to perceive a problem, decide on the course of action, and physically react within their ability to fly the aircraft. Sterile Cockpit Rule. Commonly known as the Sterile Cockpit Rule, Title 14 of the Code of Federal Regulations, 14 CFR, Section 121.542, requires flight members to refrain from non-essential activities during the critical phases of flight. As defined in the regulation, critical phases of flight are all ground operations involving taxi, takeoff, and landing, and all other operations below 10,000 feet, except cruise flight. Non-essential activities, including such activities as eating, reading a newspaper, or chatting. A series of aircraft accidents caused by flight crews who are distracted from their flight duties during critical phases of flight caused the FAA to propose the rule. While the regulation grew out of accidents in the airline industry, it holds true for the entire aviation community. Pilots can improve flight safety significantly by reducing distractions during critical phases of flight. It is important the flight instructor not only teach the concept of a sterile cockpit, but also model such behavior during flight instruction. Use of distractions. National Transportation Safety Board (NTSB) statistics reveal that most stall/spin accidents occurred when the pilot's attention was diverted from the primary task of flying the aircraft. 60% of stall/spin accidents occurred during takeoff and landing, and 20% were preceded by engine failure. Preoccupation inside or outside the flight deck while changing aircraft configuration or trim, maneuvering to avoid other traffic, or clearing hazardous obstacles during takeoff and climb could create a potential stall/spin situation. The intentional practice of stalls and spins seldom resulted in an accident. The real danger was inadvertent stalls induced by distractions during routine flight situations. Pilots at all skill levels should be aware of the increased risk of entering into an inadvertent stall or spin while performing tasks that are secondary to controlling the aircraft. The FAA has established a policy for use of certain distractions on practical tests for pilot certification. The purpose is to determine that applicants possess the skills required to cope with distractions while maintaining the degree of aircraft control required for safe flight. The most effective training is the simulation of scenarios that can lead to inadvertent stalls by creating distractions while a student is practicing certain maneuvers. Instructor responsibilities include teaching the student to divide his or her attention between the distracting task and maintaining control of the aircraft. The following are examples of distractions that can be used for this training. Drop a pencil. Ask the student to pick it up. Ask the student to determine a heading to an airport using a chart. Ask the student to reset the clock. Ask the student to get something from the back seat. Ask the student to read the outside air temperature. Ask the student to call the Automated Flight Service Station, AFSS, for weather information. Ask the student to compute true airspeed with a flight computer. Ask the student to identify terrain or objects on the ground. Ask the student to identify a field suitable for a forced landing. Have the student climb 200 feet and maintain altitude, and then descend 200 feet and maintain altitude. Have the student reverse course after a series of S-turns. It is a flight instructor's responsibility to teach the student how to take charge during a flight. A pilot in command, PIC, must know when to tell any passengers, even a DPE, when the PIC finds actions in the aircraft that distract and interfere with the safe conduct of the flight. Integrated Flight Instruction. Integrated flight instruction is flight instruction during which students are taught to perform flight maneuvers both by outside visual references and by reference to flight instruments. For this type of instruction to be fully effective, the use of instrument references should begin the first time each new maneuver is introduced. No distinction in the pilot's operation of the flight controls is permitted, regardless of whether outside references or instrument indications are used for the performance of the maneuver. When this training technique is used, instruction in the control of an aircraft by outside visual references is integrated with instruction in the use of flight instrument indications for the same operations. Development of habit patterns. It is important for the student to establish the habit of observing and relying on flight instruments from the beginning of flight training. It is equally important for the student to learn the feel of the airplane while conducting maneuvers, such as being able to feel when the airplane is out of trim or in a nose-high or nose-low attitude. Students who have been required to perform all flight maneuvers by reference to instruments as well as by outside references develop from the start the habit of continuously monitoring their own and the aircraft's performance. The early establishment of proper habits of instrument cross-check, instrument interpretation, and aircraft control is highly useful to the student. The habitual attention to instrument indications leads to improved landings because of more precise airspeed control.
Effective use of instruments also results in superior cross-country navigation, better coordination, and generally a better overall pilot competency level. General aviation accident reports provide ample support for the belief that reference to flight instruments is important to safety. The safety record of pilots who hold instrument ratings is significantly better than that of pilots with comparable flight time who have never received formal flight training for an instrument rating. Pilots in training who have been required to perform all normal flight maneuvers by reference to instruments, as well as by outside references, will develop from the start the habit of continuously monitoring their own and the aircraft's performance. The early establishment of proper habits of instrument cross-check, instrument interpretation, and aircraft control is highly useful to the student. The habits formed at this time also give him or her a firm foundation for the later training of an instrument rating. Operating efficiency. As students become proficient in monitoring and correcting their own flight technique by reference to flight instruments, the performance obtained from an aircraft increases noticeably. This is particularly true of modern complex or high-performance aircraft, which are responsive to the use of correct operating airspeeds. The use of correct power settings and climb speeds, and the accurate control of headings during climbs result in a measurable increase in climb performance. Holding precise headings and altitudes in cruising flight definitely increases average cruising performance. The use of integrated flight instruction provides the student with the ability to control an aircraft in flight for limited periods if outside references are lost. In an emergency, this ability could save the pilot's life and those of the passengers. During the conduct of integrated flight training, the flight instructor must emphasize to the students that the introduction to the use of flight instruments does not prepare them for operations in marginal weather or instrument meteorological conditions, IMC. The possible consequences, both to themselves and to others, of experiments with flight operations in weather conditions below visual flight rules, VFR minimums, before they are instrument rated, should be constantly impressed on the students. According to NTSB accident data, in-flight encounters with weather, attempting VFR flight into IMC, is one of the most lethal types of GA flying. Procedures. Integrated flight instruction begins with the first briefing on the function of the flight controls. This briefing includes the instrument indications to be expected, as well as the outside references to be used to control the attitude of the aircraft. Each new maneuver is introduced using both outside and instrument references, with students developing the ability to maneuver an aircraft equally as well by instrument or outside references. They naturally accept the fact that the manipulation of the flight controls is identical, regardless of which references are used to determine the attitude of the aircraft. This practice should continue throughout the flight instruction for all maneuvers. To fully achieve the demonstrated benefits of this type of training, the use of visual and instrument references must be constantly integrated throughout the training. Failure to do so lengthens the flight instruction necessary for the student to achieve the competency required for the private pilot certificate. See and avoid. From the start of flight training, the instructor must ensure students develop the habit of looking for other air traffic at all times. If students believe the instructor assumes all responsibility for scanning and collision avoidance procedures, they do not develop the habit of maintaining a constant vigilance, which is essential to safety. Any observed tendency of a student to enter flight maneuvers without first making a careful check for other air traffic must be corrected immediately. Recent studies of mid-air collisions determined that flight instructors were on board the aircraft in 37% of the accidents in the study. Most of the aircraft involved in collisions were engaged in recreational flying, not on any type of flight plan. Most mid-air collisions occur in VFR weather conditions during weekend daylight hours. The vast majority of accidents occurred at or near non-towered airports and at altitudes below 1,000 feet. Pilots of all experience levels were involved in mid-air collisions, from pilots on their first solo to 20,000-hour veterans. Most collisions occur in daylight with visibility greater than 3 miles. It is imperative to introduce 14 CFR Section 91.113 right-of-way rules to the student. Practice the see and avoid concept at all times regardless of whether the training is conducted under VFR or Instrument Flight Rules, IFR. For more information on how to reduce the odds of becoming involved in a mid-air collision, see www.faa.gov/about/Anchorage/Anchorage/Tracon, End of Part 1 of Chapter 8. Part 2 of Chapter 8 of Aviation Instructor's Handbook by the FAA. This LibriVox recording is in the public domain. Part 2 of Chapter 8. Assessment of Piloting Ability. Assessment is an essential component of the teaching process. It determines how, what, and how well a student is learning. A well-designed assessment provides a student with something constructive upon which he or she can work or build. An assessment should provide direction and guidance to raise the level of performance. Students must understand the purpose of the assessment, otherwise they will be unlikely to accept the evaluation offered and little improvement will result. There are many types of assessment, but the flight instructor generally uses the review, collaborative assessment, LCG, written tests, and performance-based tests to ascertain knowledge or practical skill levels. Refer to Chapter 5 for an in-depth discussion of the types of assessment available to the flight instructor. An assessment can also be used as a tool for reteaching. Although not all assessments lend themselves to reteaching, the instructor should be alert to the possibility and take advantage of the opportunity when it arises. In assessing the ability of a student, the instructor initially determines if he or she understands the procedure or maneuver. Then, the instructor demonstrates the maneuver, allows the student to practice the maneuver under direction, and finally evaluates student accomplishment by observing the performance. Demonstrated ability. Assessment of demonstrated ability during flight instruction must be based upon established standards of performance, suitably modified to apply the student's experience and stage of development as a pilot. The assessment must consider the student's mastery of the elements involved in the maneuver, rather than merely the overall performance. In order for a student to be signed off for a solo flight, the CFI must determine that the student is qualified and proficient in the flight tasks necessary for the flight. The CFI bases this assessment on the student's ability to demonstrate consistent proficiency on a number of flight maneuvers. Also associated with pilot skill evaluations during flight training are the stage checks conducted in FAA-approved school courses and their practical tests for pilot certificates and ratings. Post-flight evaluation. In assessing piloting ability, it is important for the flight instructor to keep the student informed of progress. This may be done as each procedure or maneuver is completed or summarized during the post-flight critiques. Post-flight critiques should be in a written format, such as notes to aid the flight instructor in covering all areas that were noticed during the flight or lesson. Traditionally, flight instructors explained errors in performance, pointed out elements in which the deficiencies were believed to have originated, and, if possible, suggested appropriate corrective measures. Traditional assessment depends on a grading scale of excellent, good, fair, poor, or exceeds standards, meets standards, needs more training, which often meets the instructor's needs, but not the needs of the student. With the advent of SBT, collaborative assessment is used whenever the student has completed a scenario. As discussed in Chapters 4 and 5, SBT uses a highly structured script of real-world experiences to address aviation training objectives in an operational environment. During the post-flight evaluation, collaborative assessment is used to evaluate whether certain learning criteria were met during the SBT. Collaborative assessment includes learner self-assessment and a detailed assessment by the aviation instructor. The purpose of the self-assessment is to stimulate growth in the learner's thought processes and, in turn, behaviors. The self-assessment is followed by an in-depth discussion between the instructor and the student, which compares the instructor's assessment to the student's self-assessment. First solo flight. During the student's first solo flight, the instructor must be present to assist in answering questions or resolving any issues that arise during the flight. To ensure the solo flight is a positive, confidence-building experience for the student, the flight instructor needs to consider time of day when scheduling the flight. Time of day is a factor in traffic congestion, possible winds, sun angles, and reflection. If possible, the flight instructor needs access to a portable radio during any supervised solo operations. A radio enables the instructor to terminate the solo operation if he or she observes a situation developing. The flight instructor must use good judgment when communicating with a solo student. Keep all radio communications to a minimum. Do not talk to the student on short final of the landing approach. Post-solo debriefing. During a post-solo debriefing, the flight instructor discusses what took place during the student's solo flight. It is important for the flight instructor to answer any questions the student may have as a result of a solo flight. Instructors need to be involved in all aspects of the flight to ensure the student utilizes correct flight procedures. It is very important for the flight instructor to debrief a student immediately after a solo flight. With the flight vividly etched in the student's memory, questions about the flight will come quickly. Correction of student errors. Correction of student errors should not include the practice of immediately taking the controls away when a mistake is made. Safety permitting, it is frequently better to let students progress part of the way into the mistake and find a way out. For example, in a weight shift control aircraft, the control bar is moved right to turn left. A student may show an initial tendency to move the bar in the direction of the desired turn. This tendency will dissipate with time, but allowing the student to see the effect of his or her control input is a valuable aid in illustrating the stability of the aircraft. It is difficult for the students to learn a maneuver properly if they seldom have the opportunity to correct an error. On the other hand, students may perform a procedure or maneuver correctly and not fully understand the principles or objectives involved. When the instructor suspects this, students should be required to vary the performance of the maneuver slightly, combine it with other operations, or apply the same elements to the performance of other maneuvers. Students who do not understand the principles involved will probably not be able to do this successfully. Pilot supervision. Flight instructors have the responsibility to provide guidance and restraint with respect to the solo operations of their students. This is by far the most important flight instructor responsibility. The flight instructor is the only person in a position to make the determination a student is ready for solo operations. Before endorsing a student for solo flight, the instructor should require the student to demonstrate consistent ability to perform all of the fundamental maneuvers. Dealing with normal challenges. Instructors should teach students how to solve ordinary problems encountered during flight. Traffic pattern congestion, change in active runway, or unexpected crosswinds are a challenge the student masters individually before being able to perform them collectively. Visualization. SBT lends itself well to visualization techniques. For example, have a student visualize how the flight may occur under normal circumstances, with the student describing how he or she would fly the flight. Then, the instructor adds unforeseen circumstances, such as a sudden change in weather that brings excessive winds during final approach. Other examples of SBT can have the instructor adding undesired landing sites for balloon student pilots, rope breaks for glider students, and radio outages for instrument airplane students. Now the student must visualize how he or she will handle the unexpected change. During this visualization, the flight instructor can ask questions to check the student's thought processes. The job of the instructor is to challenge the student with realistic flying situations without overburdening him or her with unrealistic scenarios. Practice landings. The FAA recommends that in all student flights involving landing in an aircraft, the flight instructor should teach a full-stop landing. Full-stop landings help the student develop aircraft control and checklist usage. Aircraft speed and control take precedence over all other actions during landings and takeoffs. Stress landing in the first third of the runway to ensure there is stopping distance for the aircraft. If the student is unable to land in the first third, teach him or her to make an immediate go-around. If the student bounces an airplane on landing, teach the student to make an immediate go-around. By following these teaching guidelines, the student is better equipped to properly execute landings when he or she solos. Furthermore, by requiring the first solo flight to consist of landings to a full stop, the flight instructor has the opportunity to stop the flight if necessary. In gliders, a low-energy landing is the most desirable, based on current winds. This helps the student develop good off-field landing techniques. This is dependent on current weather, such as excess winds including crosswinds. Practical Test Recommendations. Provision is made on the Airman Certificate or Rating Application form for the written recommendation of the flight instructor who has prepared the applicant for the practical test involved. Signing this recommendation imposes a serious responsibility on the flight instructor. A flight instructor who makes a practical test recommendation for an applicant seeking a certificate or rating should require the applicant to demonstrate thoroughly the knowledge and skill level required for that certificate or rating. This demonstration should in no instance be less than the complete procedure prescribed in the applicable PTS. When the instructor endorses the applicant for the practical test, his or her signature on the FAA Form 8710-1 Airman Certificate and/or Rating Application is valid for 60 days. This is also true with a flight proficiency endorsement that is placed in the applicant's logbook or training record. Advisory Circular AC 61-65. These two dates should be the same. Completion of prerequisites for a practical test is another instructor task that must be documented properly. Examples of all common endorsements can be found in the current issue of AC 61-65, Appendix 1. This appendix also includes references to 14 CFR Part 61, Certification, Pilots, Flight Instructors, and Ground Instructors, for more details concerning the requirements that must be met to qualify for each respective endorsement. The examples shown contain the essential elements of each endorsement. It is not mandatory, but recommended for all endorsements to be worded exactly as those in the AC. For example, changes to regulatory requirements may affect the wording, or the instructor may customize the endorsement for any special circumstances of the applicant. However, at a minimum, the instructor needs to cite the appropriate 14 CFR Part 61 section that has been completed. FAA inspectors and DPEs rely on flight instructor recommendations as evidence of qualification for certification and proof that a review has been given of the subject areas found to be deficient on the appropriate knowledge test. Recommendations also provide assurance that the applicant has been thoroughly briefed on the PTS and the associated knowledge areas, maneuvers, and procedures. If the flight instructor has trained and prepared the applicant competently, the applicant should have no problem passing the practical test. A flight instructor who fails to ensure a student meets the requirements of regulations prior to endorsing solo flight or additional rating exhibits a serious deficiency in performance. The FAA holds him or her accountable. Providing a solo endorsement for a student who is not fully prepared to accept the responsibility of solo flight operations, or providing an endorsement for an additional rating to a pilot not meeting the appropriate regulatory requirements, is also a breach of faith with the applicant. Aeronautical decision-making. As discussed on page 8-2, aviation training and flight operations are now seen as a system rather than individual concepts. The goal of system safety is for pilots to utilize all four concepts: ADM, risk management, situational awareness, and SRM, so that risk can be reduced to the lowest possible level. ADM is a systematic approach to the mental process used by aircraft pilots to consistently determine the best course of action in response to a given set of circumstances. Risk management is a decision-making process designed to systematically identify hazards, assess the degree of risk, and determine the best course of action associated with each flight. Situational awareness is the accurate perception and understanding of all the factors and conditions within the four fundamental risk elements that affect safety before, during, and after the flight. SRM is the art and science of managing all resources, both on board the aircraft and from outside sources, available to a single pilot, prior and during flight, to ensure the successful outcome of the flight. These key principles are often collectively called ADM. The importance of teaching students effective ADM skills cannot be overemphasized. While progress is continually being made in the advancement of pilot training methods, aircraft equipment and systems, and services for pilots, accidents still occur. Despite all the changes in technology to improve flight safety, one factor remains the same: the human factor. It is estimated that approximately 80% of all aviation accidents are human factors related. By taking a system approach to aviation safety, flight instructors interweave aeronautical knowledge, aircraft control skills, ADM, risk management, situational awareness, and SRM into the training process. Historically, the term pilot error has been used to describe the cause of these accidents. Pilot error means that an action or decision made by the pilot was the cause of or contributing factor to the accident. This definition also includes the pilot's failure to make a decision or take action. From a broader perspective, the phrase human factors related more aptly describes these accidents, since it is usually not a single decision that leads to an accident, but a chain of events triggered by a number of factors. The poor judgment chain, or the error chain, describes this concept of contributing factors in a human factors-related accident. Breaking one link in the chain is all that is usually necessary to change the outcome of a sequence of events. The best way to illustrate this concept to students is to discuss specific situations that lead to aircraft accidents or incidents. The following is an example of the type of scenario that could be presented to illustrate the poor judgment chain. A private pilot with 100 hours of flight time made a precautionary landing on a narrow dirt runway at a private airport. The pilot lost directional control during landing and swerved off the runway into the grass. A witness recalled later that the aircraft appeared to be too high and fast on final approach, and speculated the pilot was having difficulty controlling the aircraft in high winds. The weather at the time of the incident was reported as marginal VFR due to rain showers and thunderstorms. When the aircraft was fueled the following morning, 60 gallons of fuel were required to fill the 62-gallon capacity tanks. By discussing the events that led to this incident, instructors can help students understand how a series of judgmental errors contributed to the final outcome of this flight. Weather decision. On the morning of the flight, the pilot was running late and, having acquired a computer printout of the forecast the night before, he did not obtain a briefing from flight services before his departure. Flight planning decision/performance chart. The pilot calculated total fuel requirements for the trip based on a rule of thumb figure he had used previously for another airplane. He did not use the fuel tables printed in the pilot's operating handbook, POH, for the aircraft he was flying on this trip. After reaching his destination, the pilot did not request refueling. Based on his original calculations, he believed sufficient fuel remained for the flight home. Fatigue/failure to recognize personal limitations. In the presence of deteriorating weather, the pilot departed for the flight home at 5 p.m. He did not consider how fatigue and lack of extensive night flying experience could affect the flight. Fuel exhaustion. With the aircraft fuel almost exhausted, the pilot no longer had the option of diverting to avoid rapidly developing thunderstorms. He was forced to land at the nearest airfield available. On numerous occasions during the flight, the pilot could have made decisions which might have prevented this incident. However, as the chain of events unfolded, each poor decision left him with fewer and fewer options. On the positive side, the pilot made a precautionary landing at a time and place of his choosing. VFR into IMC accidents often lead to fatalities. In this case, the pilot landed his aircraft without loss of life. Teaching pilots to make sound decisions is the key to preventing accidents. Traditional pilot instruction has emphasized flying skills, knowledge of the aircraft, and familiarity with regulations. ADM training focuses on the decision-making process and the factors that affect a pilot's ability to make effective choices. Timely decision-making is an important tool for any pilot. The student who hesitates when prompt action is required, or who makes the decision to not decide, has made a wrong decision. Sometimes, sound ADM calls for going against procedure. For example, in the event of an engine fire, the pilot initiates an emergency descent. Some POHs call for mixture to be enriched during an emergency descent. But what if the power plant is engulfed in flames? Emergencies require the pilot to think, assess the situation, choose, and execute the actions that assure safety, not act in a rote manner. It is important for flight instructors to teach students that declaring an emergency when one occurs is an appropriate reaction. Once an emergency is declared, Air Traffic Control, ATC, gives the pilot priority handling. 14 CFR Section 91.3, Responsibility and Authority of the Pilot in Command, states that, in an in-flight emergency requiring immediate action, the pilot in command may deviate from any rule of this part to the extent required to meet that emergency. Flight instructors should incorporate ADM, risk management, situational awareness, and SRM throughout the entire training course for all levels of students. AC 60-22, Aeronautical Decision Making, provides background references, definitions, and other pertinent information about ADM training in the GA environment. Figure 8-7. The decision-making process. An understanding of the decision-making process provides students with a foundation for developing ADM skills. Some situations, such as engine failures, require a pilot to respond immediately using established procedures with little time for detailed analysis. Traditionally, pilots have been well trained to react to emergencies, but are not as well prepared to make decisions, which require a more reflective response. Typically during a flight, the pilot has time to examine any changes that occur, gather information, and assess risk before reaching a decision. The steps leading to this conclusion constitute the decision-making process. When the decision-making process is presented to students, it is essential to discuss how the process applies to an actual flight situation. To explain the decision-making process, the instructor can introduce the following steps with the accompanying scenario that places the students in the position of making a decision about a typical flight situation. Defining the problem. The first step in the decision-making process is to define the problem. This begins with recognizing that a change has occurred or that an expected change did not occur. A problem is perceived first by the senses and then is distinguished through insight and experience. These same abilities, as well as an objective analysis of all available information, are used to determine the exact nature and severity of the problem. One critical error that can be made during the decision-making process is incorrectly defining the problem. For example, failure of a landing gear extended light to illuminate could indicate that the gear is not down and locked into place, or it could mean that the bulb is burned out. The actions to be taken in each of these circumstances would be significantly different. Fixating on a problem that does not exist can divert the pilot's attention from important tasks. The pilot's failure to maintain an awareness of the circumstances regarding the flight now becomes the problem. That is why, once an initial assumption is made regarding the problem, other sources must be used to verify the pilot's conclusion is correct. While on a cross-country flight, Brenda discovers her time en route between two checkpoints is significantly longer than the time she originally calculated. By noticing this discrepancy, she has recognized a change. Based on insight, cross-country flying experience, and knowledge of weather systems, she considers the possibility that she has an increased headwind. She verifies that the original calculations are correct and considers factors that may have lengthened the time between checkpoints, such as a climb or deviation off course. To determine if there is a change in the winds aloft forecast and to check recent pilot reports, she contacts FlightWatch. After weighing each information source, she concludes that the headwind has increased.
To determine the severity of the problem, she calculates a new ground speed and reassesses fuel requirements. Choosing a course of action. After the problem has been identified, the pilot evaluates the need to react to it and determines the actions that may be taken to resolve the situation in the time available. The expected outcome of each possible action should be considered and the risks assessed before the pilot decides on a response to the situation. Brenda determines the fuel burn if she continues to her destination and considers other options: turning around and landing at a nearby airport, diverting off course, or landing prior to her destination at an airport en route. She considers the expected outcome of each possible action and assesses the risks involved. After studying the chart, she concludes there is an airport which has refueling services within a reasonable distance along her route. She can refuel there and continue to her destination without a significant loss of time. Implementing the decision and evaluating the outcome. Although a decision may be reached and a course of action implemented, the decision-making process is not complete. It is important to think ahead and determine how the decision could affect other phases of the flight. As the flight progresses, the pilot must continue to evaluate the outcome of the decision to ensure that it is producing the desired result. To implement her decision, Brenda plots the course changes and calculates a new estimated time of arrival. She also contacts the nearest AFSS to amend her flight plan and check weather conditions at the new destination. As she proceeds to the airport, she continues to monitor ground speed, aircraft performance, and weather conditions to ensure no additional steps need to be taken to guarantee the safety of the flight. Factors affecting decision-making. It is important to stress to a student that being familiar with the decision-making process does not ensure he or she has the good judgment to be a safe pilot. The ability to make effective decisions as PIC depends on a number of factors. Some circumstances, such as the time available to make a decision, may be beyond the pilot's control. However, a pilot can learn to recognize these factors that can be managed and learn skills to improve decision-making ability and judgment. Recognizing hazardous attitudes. While the ADM process does not eliminate errors, it helps the pilot recognize errors and, in turn, enables the pilot to manage the error to minimize its effects. 2 steps to improve flight safety are identifying personal attitudes hazardous to flight safety and learning behavior modification techniques. Flight instructors must be able to spot hazardous attitudes in a student because the recognition of hazardous thoughts is the first step toward neutralizing them. CFIs should keep in mind that being fit to fly depends on more than just a pilot's physical condition and recency of experience. Hazardous attitudes contribute to poor pilot judgment and affect the quality of decisions. Attitude can be defined as a personal, motivational predisposition to respond to persons, situations, or events in a given manner. Studies have identified 5 hazardous attitudes that can affect a pilot's ability to make sound decisions and exercise authority properly. Figure 8-8. Figure 8-8 text. Pilots should examine their decisions carefully to ensure that their choices have not been influenced by a hazardous attitude. The 5 hazardous attitudes. Anti-authority. Don't tell me. This attitude is found in people who do not like anyone telling them what to do. In a sense, they are saying, "No one can tell me what to do." They may be resentful of having someone tell them what to do, or may regard rules, regulations, and procedures as silly or unnecessary. However, it is always pilot prerogative to question authority if it seems to be in error. Impulsivity. Do it quickly. This is the attitude of people who frequently feel the need to do something, anything, immediately. They do not stop to think about what they are about to do. They do not select the best alternative, and they do the first thing that comes to mind. Invulnerability. It won't happen to me. Many people believe that accidents happen to others, but never to them. They know accidents can happen, and they know that anyone can be affected. They never really feel or believe that they will be personally involved. People who think this way are more likely to take chances and increase risk. Macho. I can do it. Pilots who are always trying to prove that they are better than anyone else are thinking, I can do it. I'll show them. Pilots with this type of attitude will try to prove themselves by taking risks in order to impress others. While this pattern is thought to be a male characteristic, women are equally susceptible. Resignation. What's the use? Pilots who think, "What's the use?" do not see themselves as being able to make a great deal of difference in what happens to them. When things go well, the pilot is apt to think that it is good luck. When things go badly, the pilot may feel that someone is out to get me, or attribute it to bad luck. The pilot will leave the action to others, for better or worse. Sometimes such pilots will even go along with unreasonable requests just to be a nice guy. End of Figure 8-8 text. In order for a student to self-examine behaviors during flight, he or she must be taught the potential risks caused from hazardous attitudes and, more importantly, the antidote for each. Figure 8-9. For example, if a student has an easy time with flight training and seems to understand things very quickly, there may be a potential for that student to have a macho, hazardous attitude. A successful CFI points out the potential for the behavior and teaches the student the antidote for that attitude. Hazardous attitudes need to be noticed immediately and corrected with a proper antidote to minimize the potential for any flight hazard. Figure 8-9. Text. Students in training can be asked to identify hazardous attitudes and the corresponding antidotes when presented with flight scenarios. Hazardous attitude. Macho. Steve often brags to his friends about his skills as a pilot and how close to the ground he flies. During a local pleasure flight in a single-engine airplane, he decides to buzz some friends barbecuing at a nearby park. Antidote. Taking chances is foolish. Hazardous attitude. Anti-authority. Although he knows that flying so low to the ground is prohibited by the regulations, he feels that the regulations are too restrictive in some circumstances. Antidote. Follow the rules. They are usually right. Hazardous attitude. Invulnerability. Steve is not worried about an accident since he has flown this low many times before and he has not had any problems. Antidote. It could happen to me. Hazardous attitude. Impulsivity. As he is buzzing the park, the airplane does not climb as well as Steve had anticipated, and, without thinking, he pulls back hard on the yoke. The airspeed drops and the airplane is close to stalling as the wing brushes a power line. Antidote. Not so fast. Think first. Hazardous attitude. Resignation. Although Steve manages to recover, the wing sustains minor damage. Steve thinks to himself, "It doesn't really matter how much effort I put in. The end result is the same whether I really try or not." Antidote. I'm not helpless. I can make a difference. End of Figure 8-9 text. Stress management. Learning how to recognize and cope with stress is another effective ADM tool. Stress is the body's response to demands placed upon it. These demands can be either pleasant or unpleasant in nature. The causes of stress for a pilot can range from unexpected weather or mechanical problems while in flight to personal issues unrelated to flying. Stress is an inevitable and necessary part of life. It adds motivation and heightens the individual's response to meet any challenge. Everyone is stressed to some degree all the time. A certain amount of stress is good since it keeps a person alert and prevents complacency. However, the effects of stress are cumulative, and, if not coped with adequately, they eventually add up to an intolerable burden. Performance generally increases with the onset of stress, peaks, and then begins to fall off rapidly as stress levels exceed a person's ability to cope. The ability to make effective decisions during flight can be impaired by stress. Factors, referred to as stressors, can increase a pilot's risk of error in the flight deck. Figure 8-10. Figure 8-10 text. 3 types of stressors that can affect pilot performance. Physical stress, conditions associated with the environment such as temperature and humidity, noise, vibration, and lack of oxygen. Physiological stress, physical conditions such as fatigue, lack of physical fitness, sleep loss, missed meals leading to low blood sugar levels, and illness. Psychological stress, Social or emotional factors, such as a death in the family, a divorce, a sick child, or a demotion at work. This type of stress may also be related to mental workload, such as analyzing a problem, navigating an aircraft, or making decisions. End of Figure 8-10 text. One way of exploring the subject of stress with a student is to recognize when stress is affecting performance. If a student seems distracted or has a particularly difficult time accomplishing the tasks of the lesson, the instructor can query the student. Was the student uncomfortable or tired during the flight? Is there some stress in another aspect of the student's life that may be causing a distraction? This may prompt the student to evaluate how these factors affect performance and judgment. The instructor should also try to determine if there are aspects of pilot training that are causing excessive amounts of stress for the student. For example, if the student consistently makes the decision not to fly, even though weather briefings indicate favorable conditions, it may be due to apprehension regarding the lesson content. Stalls, landings, or an impending solo flight may cause concern. By explaining a specific maneuver in greater detail or offering some additional encouragement, the instructor may be able to alleviate some of the student's stress. To help students manage the accumulation of life stresses and prevent stress overload, instructors can recommend several techniques. For example, including relaxation time in a busy schedule and maintaining a program of physical fitness can help reduce stress levels. Learning to manage time more effectively can help pilots avoid heavy pressures imposed by getting behind schedule and not meeting deadlines. While these pressures may exist in the workplace, students may also experience the same type of stress regarding their flight training schedule. Instructors can advise students to self-assess to determine their capabilities and limitations and then set realistic goals. In addition, avoiding stressful situations and encounters can help pilots cope with stress. Use of resources. To make informed decisions during flight operations, students must be made aware of the resources found both inside and outside the flight deck. Since useful tools and sources of information may not always be readily apparent, learning to recognize these resources is an essential part of ADM training. Resources must not only be identified, but students must also develop the skills to evaluate whether they have the time to use a particular resource and the impact that its use would have upon the safety of flight. For example, the assistance of ATC may be very useful if a pilot is lost. However, in an emergency situation when action needs to be taken quickly, time may not be available to contact ATC immediately. During training, CFIs can routinely point out resources to students. Internal resources. Internal resources are found in the flight deck during flight. Since some of the most valuable internal resources are ingenuity, knowledge, and skill, pilots can expand flight deck resources immensely by improving their capabilities. This can be accomplished by frequently reviewing flight information publications, such as 14 CFR and the Aeronautical Information Manual, AIM, as well as by pursuing additional training. A thorough understanding of all the equipment and systems in the aircraft is necessary to fully utilize all resources. For example, advanced navigation and autopilot systems are valuable resources flight instructors must ensure students know how to use. If students do not fully understand how to make use of the equipment, or if they rely on it so much that they become complacent, it can become a detriment to safe flight. With the advent of advanced avionics with glass displays, GPS, and autopilot, flying may seem inherently easier and safer, but in reality it has become more complex. With the update of the Instrument Practical Test Standards, PTS, to include electronic flight instrument displays, flight management systems, GPS, and autopilot usage, knowledge of internal resources becomes an important component of flight training. As discussed in the section on flight instructor qualifications, instructors must be familiar with the components of each aircraft in which they instruct,
to ensure students understand the operation of the equipment. Checklists are essential flight deck resources for verifying that the aircraft instruments and systems are checked, set, and operating properly, as well as ensuring that the proper procedures are performed if there is a system malfunction or in-flight emergency. Students reluctant to use checklists can be reminded that pilots at all levels of experience refer to their checklists, and that the more advanced the aircraft is, the more critical checklists become. With the advent of electronic checklists, it has become easier to develop and maintain personal checklists from the manufacturer's checklist with additions for specific aircraft and operations. In addition, the AFM/POH, which is required to be carried on board the aircraft, is essential for accurate flight planning and for resolving in-flight equipment malfunctions. Other valuable flight deck resources include current aeronautical charts and publications, such as the Airport/Facility Directory, A/FD. It should be pointed out to students that passengers can also be a valuable resource. Passengers can help watch for traffic and may be able to provide information in an irregular situation, especially if they are familiar with flying. A strange smell or sound may alert a passenger to a potential problem. The PIC should brief passengers before the flight to make sure that they are comfortable voicing any concerns. External resources. Possibly the greatest external resources during flight are air traffic controllers and flight service specialists. ATC can help decrease pilot workload by providing traffic advisories, radar vectors, and assistance in emergency situations. AFSS can provide updates on weather, answer questions about airport conditions, and may offer direction-finding assistance. The services provided by ATC can be invaluable in enabling pilots to make informed in-flight decisions. Instructors can help new students feel comfortable with ATC by encouraging them to take advantage of services, such as flight following and flight watch. If students are exposed to ATC as much as possible during training, they feel confident asking controllers to clarify instructions and are better equipped to use ATC as a resource for assistance in unusual circumstances or emergencies. Throughout training, students can be asked to identify internal and external resources, which can be used in a variety of flight situations. For example, if a discrepancy is found during pre-flight, what resources can be used to determine its significance? In this case, the student's knowledge of the aircraft, the POH, an instructor or other experienced pilot, or an AMT, can be a resource which may help define the problem. During cross-country training, students may be asked to consider the following situation. On a cross-country flight, you become disoriented. Although you are familiar with the area, you do not recognize any landmarks and fuel is running low. What resources do you have to assist you? Students should be able to identify their own skills and knowledge, aeronautical charts, ATC, flight service, and navigation equipment as some of the resources that can be used in this situation. Workload management. Effective workload management ensures the essential operations are accomplished by planning, prioritizing, and sequencing tasks to avoid work overload. As experience is gained, a pilot learns to recognize future workload requirements and can prepare for high workload periods during times of low workload. Instructors can teach this skill by prompting their students to prepare for a high workload. For example, when en route, the student can be asked to explain the actions that need to be taken during the approach to the airport. The student should be able to describe the procedures for traffic pattern entry and landing preparation. Reviewing the appropriate chart and setting radio frequencies well in advance of need helps reduce workload as the flight nears the airport. In addition, the student should listen to the Automatic Terminal Information Service, ATIS, Automated Surface Observing Systems, ASOS, or Automated Weather Observing System, AWOS, if available, and then monitor the Tower Frequency or Common Traffic Advisory Frequency, CTAF, to get a good idea of what traffic conditions to expect. Checklists should be performed well in advance so there is time to focus on traffic and ATC instructions. These procedures are especially important prior to entering a high-density traffic area such as Class B airspace. To manage workload, items should be prioritized. This concept should be emphasized to students and reinforced when training procedures are performed. For example, during a go-around, adding power, gaining airspeed, and properly configuring the aircraft are priorities. Informing the tower of the balked landing should be accomplished only after these tasks are completed. Students must understand that priorities change as the situation changes. If fuel quantity is lower than expected on a cross-country flight, the priority can shift from making a scheduled arrival at the destination to locating a nearby airport to refuel. In an emergency situation, the first priority is to fly the aircraft and maintain a safe airspeed. Another part of managing workload is recognizing a work overload situation. The first effect of high workload is that the pilot begins to work faster. As workload increases, attention cannot be devoted to several tasks at one time, and the pilot may begin to focus on one item. When the pilot becomes task-saturated, there is no awareness of inputs from various sources. Decisions may be made on incomplete information, and the possibility of error increases. Figure 8-11. During a lesson, workload can be gradually increased as the instructor monitors the student's management of tasks. The instructor should ensure that the student has the ability to recognize a work overload situation. When becoming overloaded, the student should stop, think, slow down, and prioritize. It is important that the student understand options that may be available to decrease workload. For example, locating an item on a chart or setting a radio frequency may be delegated to another pilot or passenger. An autopilot, if available, may be used, or ATC may be enlisted to provide assistance. Chapter Summary. This chapter discussed the demonstration, performance, and telling and doing, training delivery methods of flight instruction, SBT techniques, practical strategies flight instructors can use to enhance their instruction, integrated flight instruction, positive exchange of flight controls, use of distractions, obstacles to learning encountered during flight training, and how to evaluate students. After an intensive look at ADM with suggestions for how to interweave ADM, risk management, and SRM into the teaching process, it closes with a discussion of CFI recommendations. Additional information on recommendations and endorsements can be found in Appendix E, Flight Instructor Endorsements. End of Chapter 8. Chapter 9 of Aviation Instructor's Handbook. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Aviation Instructor's Handbook, FAA-H-8083-9A. Chapter 9. Risk Management. Introduction. Pull the throttle back. Lenore, a certificated flight instructor, CFI, ordered the student, Jennifer, as the revolutions per minute, RPM, climbed past 2,000 on engine startup. I did. Both Jennifer and Lenore grabbed the mixture and pulled. The engine went from a deafening roar to silence. They looked at each other. What happened? Asked Jennifer. I don't know. Let's check the engine, Lenore said. 10 minutes later, they had removed the cowling from the Cessna 152. A quick engine check gave them the answer. The throttle rod end was not connected to the carburetor arm. No bolt, no nut, just air between the rod end and the arm. Jennifer looked at Lenore. What if this happened in flight? What I want to know, Lenore said, is how this happened at all. The annual inspection was signed off yesterday. The previous day, the annual inspection had been signed off after a lengthy inspection by a local facility. Several mechanics had been involved in the inspection, including the owner/student who had installed a headliner. The mechanic with the inspection authorization, IA, who signed off the annual, was supervising several annuals, so most of the maintenance was performed by other mechanics. After the inspection, the engine had been run up according to the usual post-inspection procedures. The student and instructor had flown the airplane for a half-hour familiarization flight. The next day's engine start resulted in a runaway engine, with the apparent cause due to the lack of a throttle rod end hardware being safetied. 3 deficient areas in this annual inspection were identified by a roundtable discussion group of aircraft and power plant, A&P, mechanics, and the student. These areas were lack of responsibility, checklist misuse, complacency. Lack of responsibility. No one took responsibility for the entire inspection. The chances of something being overlooked increase with an increase in the number of mechanics involved in an inspection. The responsible person is removed from the actual procedure. The student remembers hearing the IA ask one of the engine mechanics about the throttle. However, the question was vague, the answer was vague, and the rod end was not safetied. Checklist misuse. All checklists have a line item regarding inspection of the engine controls for rigging and safety. Perhaps the throttle rod end had been disconnected for maintenance after the IA had signed off the control inspection. In that case, a discrepancy should have been entered onto the discrepancy sheet stating reconnect and safety throttle rod end. Complacency. An insidious and hard-to-identify attitude. Each of the mechanics involved in the incident thought someone else had inspected the throttle rod end. The IA signed off the annual inspection because he had either asked the mechanics about the items on the checklist or, in his frequent visits to the airplane, had inspected the various items himself and decided that was good enough. Complacency crippled the mechanic's quality of work by removing any thoughts of double-checking each other's work. While a definite answer to the question of what happened remains a matter of speculation, professional mechanics should heed warning signs of potential problems. The combination of a lengthy inspection, numerous technicians, an overworked supervisor, a poor checklist, and vague communication should raise a red flag of caution. Although the ultimate responsibility for the safety of any flight rests with the pilot in command, PIC, it is not unreasonable for the PIC to assume that mechanics also take their responsibilities seriously. This scenario underscores the need for safety risk management at all levels of aviation. Safety risk management, a formal system of hazard identification and analysis, is essential for keeping risk at acceptable levels. Part of this process is selecting the appropriate controls to mitigate the risk of the identified hazard. The primary objective of risk management is accident prevention, which is achieved by proactively identifying, assessing, and eliminating or controlling safety-related hazards to acceptable levels. This chapter discusses safety risk management in the aviation community, looking at it as preemptive rather than reactive. The principles of risk management and the tools for teaching risk management in the flight training environment are addressed in Chapter 8, Techniques of Flight Instruction. Defining risk management. Risk is defined as the probability and possible severity of accident or loss from exposure to various hazards, including injury to people and loss of resources. Figure 9-1. All Federal Aviation Administration (FAA) operations in the United States involve risk and require decisions that include risk assessment and risk management. Risk management, a formalized way of thinking about these topics, is the logical process of weighing the potential costs of risks against the possible benefits of allowing these risks to stand uncontrolled. Risk management is a decision-making process designed to identify hazards systematically, assess degree of risk, and determine the best course of action. Key terms are hazard, a present condition, event, object, or circumstance that could lead to or contribute to an unplanned or undesired event, such as an accident. It is a source of danger. For example, a nick in the propeller represents a hazard. Risk. The future impact of a hazard that is not controlled or eliminated. It is the possibility of loss or injury.
The level of risk is measured by the number of people or resources affected, exposure, the extent of possible loss, severity, and the likelihood of loss, probability. Safety, freedom from those conditions that can cause death, injury, occupational illness, or damage to or loss of equipment or property, or damage to the environment. Note that absolute safety is not possible because complete freedom from all hazardous conditions is not possible. Therefore, safety is a relative term that implies a level of risk that is both perceived and accepted. Figure 9-1, Text. Types of risk. Total risk, the sum of identified and unidentified risks. Identified risk. Risk which has been determined through various analysis techniques. The first task of system safety is to identify, within practical limitations, all possible risks. Unidentified risk. Risk not yet identified. Some unidentified risks are subsequently identified when a mishap occurs. Some risk is never known. Unacceptable risk. Risk which cannot be tolerated by the managing activity. It is a subset of identified risk that must be eliminated or controlled. Acceptable risk. Acceptable risk is the part of identified risk that is allowed to persist without further engineering or management action. Making this decision is a difficult yet necessary responsibility of the managing activity. This decision is made with full knowledge that it is the user who is exposed to the risk. Residual risk. Residual risk is the risk left over after system safety efforts have been fully employed. It is not necessarily the same as acceptable risk. Residual risk is the sum of acceptable risk and unidentified risk. This is the total risk passed on to the user. End of Figure 9-1 text. Principles of risk management. Accept no unnecessary risk. Unnecessary risk is that which carries no commensurate returns in terms of benefits or opportunities. Everything involves risk. The most logical choices for accomplishing an operation are those that meet all requirements with a minimum acceptable risk. The corollary to this axiom is accept necessary risk required to complete the operation or task successfully. Flying is impossible without risk, but unnecessary risk comes without a corresponding return. If flying a new airplane for the first time, a CFI might determine that the risk of making the flight in low instrument flight rules, IFR, conditions is unnecessary. Make risk decisions at the appropriate level. Anyone can make a risk decision. However, the appropriate decision maker is the person who can develop and implement risk controls. The decision maker must be authorized to accept levels of risk typical of the planned operation. In a single pilot situation, the pilot makes the decision to accept certain levels of risk. In the maintenance facility, an aviation maintenance technician, AMT, may need to elevate decisions to the next level in the chain of management upon determining that those controls available to him or her will not reduce residual risk to an acceptable level. Accept risk when benefits outweigh the costs. All identified benefits should be compared against all identified costs. Even high-risk endeavors may be undertaken when there is clear knowledge that the sum of the benefits exceeds the sum of the costs. For example, in any flying activity, it is necessary to accept some degree of risk. A day of good weather, for example, is a much better time to fly an unfamiliar airplane for the first time than a day with low instrument flight rules, IFR conditions. Integrate risk management into planning at all levels. Risks are more easily assessed and managed in the planning stages of an operation. The later changes are made in the process of planning and executing an operation, the more expensive and time-consuming they become. Because risk is an unavoidable part of every flight, safety requires the use of appropriate and effective risk management, not just in the pre-flight planning stage, but in all stages of the flight. Risk management process. Risk management is a simple process which identifies operational hazards and takes reasonable measures to reduce risk to personnel, equipment, and the mission. Step 1. Identify the hazard. A hazard is defined as any real or potential condition that can cause degradation, injury, illness, death, or damage to, or loss of equipment or property. Experience, common sense, and specific analytical tools help identify risks. Step 2. Assess the risk. The assessment step is the application of quantitative and qualitative measures to determine the level of risk associated with specific hazards. This process defines the probability and severity of an accident that could result from the hazards based upon the exposure of humans or assets to the hazards. Step 3. Analyze risk control measures. Investigate specific strategies and tools that reduce, mitigate, or eliminate the risk. All risks have two components. 1. Probability of occurrence. 2. Severity of the hazard. Effective control measures reduce or eliminate at least one of these. The analysis must take into account the overall costs and benefits of remedial actions, providing alternative choices if possible. Step 4. Make control decisions. Identify the appropriate decision maker. That decision maker must choose the best control or combination of controls based on the analysis of steps 1 and 2. Step 5. Implement risk controls. A plan for applying the selected controls must be formulated. The time, materials, and personnel needed to put these measures in place must be provided. Step 6. Supervise and review. Once controls are in place, the process must be re-evaluated periodically to ensure their effectiveness. People at every level must fulfill their respective roles to assure the controls are maintained over time. The risk management process continues throughout the life cycle of the system, mission, or activity. Implementing the risk management process. To derive maximum benefit from this powerful tool, it must be used properly. The following principles are essential. Apply the steps in sequence. Each step is a building block for the next and must be completed before proceeding to the next. If a hazard identification step is interrupted to focus on the control of a particular hazard, more important hazards may be overlooked. Until all hazards are identified, the remainder of the process is not effective. Maintain a balance in the process. All steps are important. Allocate the time and resources to perform all. Apply the process in a cycle. The supervise and review step should include a brand new look at the operation being analyzed to see whether new hazards can be identified. Involve people in the process. Ensure that risk controls are mission supportive, and the people who must do the work see them as positive actions. The people who are actually exposed to risks usually know best what works and what does not. Level of risk. The level of risk posed by a given hazard is measured in terms of severity, extent of the possible loss, probability, likelihood that a hazard will cause a loss. Assessing risk. Assessment of risk is an important part of good risk management. For example, the hazard of a nick in the propeller poses a risk only if the airplane is flown. If the damaged prop is exposed to the constant vibration of normal engine operation, there is a high risk that it could fracture and cause catastrophic damage to the engine and/or airframe and the passengers. Every flight has hazards and some level of risks associated with it. It is critical that pilots, and especially students, are able to differentiate in advance between a low-risk flight and a high-risk flight, and then establish a review process and develop risk mitigation strategies to address flights throughout that range. For the single pilot, assessing risk is not as simple as it sounds. For example, the pilot acts as his or her own quality control in making decisions. If a fatigued pilot who has flown 16 hours is asked if he or she is too tired to continue flying, the answer may be no. Most pilots are goal-oriented, and when asked to accept a flight, there is a tendency to deny personal limitations while adding weight to issues not germane to the mission. For example, pilots of helicopter emergency services, EMS, have been known to make flight decisions that add significant weight to the patient's welfare. These pilots add weight to intangible factors, the patient in this case, and fail to appropriately quantify actual hazards such as fatigue or weather when making flight decisions. The single pilot, who has no other crew member for consultation, must wrestle with the intangible factors that draw one into a hazardous position. Therefore, he or she has greater vulnerability than a full crew. Examining National Transportation Safety Board (NTSB) reports and other accident research can help a pilot learn to assess risk more effectively. For example, the accident rate during night VFR decreases by nearly 50% once a pilot obtains 100 hours and continues to decrease until the 1,000-hour level. The data suggest that for the first 500 hours, pilots flying VFR at night might want to establish higher personal limitations than are required by the regulations and, if applicable, apply instrument flying skills to this environment. Several risk assessment models are available to assist in the process of assessing risk. The models, all taking slightly different approaches, seek a common goal of assessing risk in an objective manner. The most basic tool is the risk matrix, Figure 9-2. It assesses two items: the likelihood of an event occurring and the consequences of that event. Likelihood of an event. Likelihood is nothing more than taking a situation and determining the probability of its occurrence. It is rated as probable, occasional, remote, or improbable. For example, a pilot is flying from point A to point B, 50 miles, in marginal visual flight rules, MVFR, conditions. The likelihood of encountering potential instrument meteorological conditions, IMC, is the first question the pilot needs to answer. The experiences of other pilots, coupled with the forecast, might cause the pilot to assign occasional to determine the probability of encountering IMC. The following are guidelines for making assignments. Probable. An event will occur several times. Occasional. An event will probably occur sometime. Remote. An event is unlikely to occur, but is possible. Improbable. An event is highly unlikely to occur. Severity of an event. The next element is the severity or consequences of a pilot's actions. It can relate to injury and/or damage. If the individual in the example above is not an Instrument Flight Rules (IFR) pilot, what are the consequences of encountering inadvertent IMC? In this case, because the pilot is not IFR rated, the consequences are catastrophic. The following are guidelines for this assignment. Catastrophic. Results in fatalities, total loss. Critical. Severe injury, major damage. Marginal. Minor injury, minor damage. Negligible. Less than minor injury, less than minor system damage. Simply connecting the two factors as shown in Figure 9-2 indicates the risk is high and the pilot must either not fly or fly only after finding ways to mitigate, eliminate, or control the risk. Mitigating risk. Risk assessment is only part of the equation. After determining the level of risk, the pilot needs to mitigate the risk. For example, the pilot flying from point A to point B, 50 miles, in MVFR conditions has several ways to reduce risk. Wait for the weather to improve to good visual flight rules, VFR conditions. Take a pilot who is rated as an IFR pilot. Delay the flight. Cancel the flight. Drive. I'm safe, IMSAFE checklist. One of the best ways that single pilots can mitigate risk is to use the I'm safe checklist, Figure 9-3, to determine physical and mental readiness for flying. 1. Illness.
Am I sick? Illness is an obvious pilot risk. 2. Medication. Am I taking any medicines that might affect my judgment or make me drowsy? 3. Stress. Am I under psychological pressure from the job? Do I have money, health, or family problems? Stress causes concentration and performance problems. While the regulations list medical conditions that require grounding, stress is not among them. The pilot should consider the effects of stress on performance. 4. Alcohol. Have I been drinking within 8 hours? Within 24 hours? As little as 1 ounce of liquor, 1 bottle of beer, or 4 ounces of wine can impair flying skills. Alcohol also renders a pilot more susceptible to disorientation and hypoxia. 5. Fatigue. Am I tired and not adequately rested? Fatigue continues to be one of the most insidious hazards to flight safety, as it may not be apparent to a pilot until serious errors are made. 6. Eating. Have I eaten enough of the proper foods to keep adequately nourished during the entire flight? The PAVE checklist. Another way to mitigate risk is to perceive hazards. By incorporating the PAVE checklist into all stages of flight planning, the pilot divides the risks of flight into 4 categories. P. Pilot in command, PIC. A. Aircraft. V. Environment. And E. External pressures, PAVE, which form part of the pilot's decision-making process. With the PAVE checklist, pilots have a simple way to remember each category to examine for risk prior to each flight. Once a pilot identifies the risk of a flight, he or she needs to decide whether the risk or combination of risks can be managed safely and successfully. If not, make the decision to cancel the flight. If the pilot decides to continue with the flight, he or she should develop strategies to mitigate the risks. One way a pilot can control the risks is to set personal minimums for items in each risk category. These are limits unique to that individual pilot's current level of experience and proficiency. For example, the aircraft may have a maximum crosswind component of 15 knots listed in the Aircraft Flight Manual, AFM, and the pilot has experience with 10 knots of direct crosswind. It could be unsafe to exceed 10 knots crosswind component without additional training. Therefore, the 10 knots crosswind experience level is that pilot's personal limitation until additional training with a certificated flight instructor, CFI, provides the pilot with additional experience for flying in crosswinds that exceed 10 knots. One of the most important concepts that safe pilots understand is the difference between what is legal in terms of the regulations and what is smart or safe in terms of pilot experience and proficiency. P equals pilot in command, PIC. The pilot is one of the risk factors in a flight. The pilot must ask, am I ready for this trip? In terms of experience, currency, physical and emotional conditions, the I'm safe checklist, combined with proficiency, recency, and currency, provides the answers. A equals aircraft. What limitations will an aircraft impose upon the trip? Ask the following questions. Is this the right aircraft for the flight? Am I familiar with and current in this aircraft? Aircraft performance figures and the AFM are based on a brand new aircraft flown by a professional test pilot. Keep that in mind while assessing personal and aircraft performance. Is this aircraft equipped for the flight? Instruments, lights, navigation, and communication equipment adequate? Can this aircraft use the runways available for the trip with an adequate margin of safety under the conditions to be flown? Can this aircraft carry the planned load? Can this aircraft operate at the altitudes needed for the trip? Does this aircraft have sufficient fuel capacity with reserves for trip legs planned? Does the fuel quantity delivered match the fuel quantity ordered? V equals environment. Weather is a major environmental consideration. Earlier, it was suggested pilots set their own personal minimums, especially when it comes to weather. As pilots evaluate the weather for a particular flight, they should consider the following. What are the current ceiling and visibility? In mountainous terrain, consider having higher minimums for ceiling and visibility, particularly if the terrain is unfamiliar. Consider the possibility that the weather may be different than forecast. Have alternative plans and be ready and willing to divert should an unexpected change occur. Consider the winds at the airports being used and the strength of the crosswind component. If flying in mountainous terrain, consider whether there are strong winds aloft. Strong winds in mountainous terrain can cause severe turbulence and downdrafts and can be very hazardous for aircraft even when there is no other significant weather. Are there any thunderstorms present or forecast? If there are clouds, is there any icing, current, or forecast? What is the temperature dew point spread and the current temperature at altitude? Can descent be made safely all along the route? If icing conditions are encountered, is the pilot experienced at operating the aircraft's de-icing or anti-icing equipment? Is this equipment in good condition and functional? For what icing conditions is the aircraft rated, if any? Evaluation of terrain is another important component of analyzing the flight environment. To avoid terrain and obstacles, especially at night or in low visibility, determine safe altitudes in advance by using altitudes shown on VFR and IFR charts during pre-flight planning. Use maximum elevation figures, MEFs, and other easily obtainable data to minimize chances of an in-flight collision with terrain or obstacles. Airport considerations include what lights are available at the destination and alternate airports. VASI/PAPI or ILS glide slope guidance? Is the terminal airport equipped with them? Are they working? Will the pilot need to use the radio to activate the airport lights? Check the notices to airmen, NOTAMs, NOTAMs, for closed runways or airports. Look for runway or beacon lights out, nearby towers, etc. Choose the flight route wisely. An engine failure gives the nearby airports and terrain supreme importance. Are there shorter or obstructed fields at the destination and/or alternate airports? Airspace considerations include if the trip is over remote areas, are appropriate clothing, water, and survival gear on board in the event of a forced landing? If the trip includes flying over water or unpopulated areas with a chance of losing visual reference to the horizon, the pilot must be current, equipped, and qualified to fly IFR. Check the airspace and temporary flight restrictions, TFRs, along the route of flight. Night flying requires special consideration. If the trip includes flying at night over water or unpopulated areas with a chance of losing visual reference to the horizon, the pilot must be prepared to fly IFR. Will the flight conditions allow a safe emergency landing at night? Pre-flight, all aircraft lights, interior and exterior, for night flight. Carry at least 2 flashlights, one for exterior pre-flight and a smaller one that can be dimmed and kept nearby. E equals external pressures. External pressures are influences external to the flight that create a sense of pressure to complete a flight, often at the expense of safety. Factors that can be external pressures include the following: someone waiting at the airport for the flight's arrival, a passenger the pilot does not want to disappoint, the desire to demonstrate pilot qualifications, the desire to impress someone. Probably the 2 most dangerous words in aviation are "watch this." The desire to satisfy a specific personal goal. Get home itis, get there itis, and let's go itis. The pilot's general goal completion orientation. Emotional pressure associated with acknowledging that skill and experience levels may be lower than a pilot would like them to be. Pride can be a powerful external factor. Management of external pressure is the single most important key to risk management
because it is the one risk factor category that can cause a pilot to ignore all the other risk factors. External pressures put time-related pressure on the pilot and figure into a majority of accidents. The use of Personal Standard Operating Procedures, SOPs, is one way to manage external pressures. The goal is to supply a release for the external pressures of a flight. These procedures include, but are not limited to, allow time on a trip for an extra fuel stop or to make an unexpected landing because of weather, have alternate plans for a late arrival, or make backup airline reservations for must-be-there trips. For really important trips, plan to leave early enough so that there would still be time to drive to the destination. Advise those who are waiting at the destination that the arrival may be delayed. Know how to notify them when delays are encountered. Manage passenger expectations. Make sure passengers know that they might not arrive on a firm schedule, and if they must arrive at a certain time, they should make alternative plans. Eliminate pressure to return home, even on a casual day flight, by carrying a small overnight kit containing prescriptions, contact lens solutions, toiletries, or other necessities on every flight. The key to managing external pressure is to be ready for and accept delays. Remember that people get delayed when traveling on airlines, driving a car, or taking a bus. The pilot's goal is to manage risk, not create hazards. During each flight, decisions must be made regarding events involving interactions between the four risk elements: PIC, aircraft, environment, and external pressures. The decision-making process involves an evaluation of each of these risk elements to achieve an accurate perception of the flight situation. Figure 9-4. 3P model for pilots. Risk management is a decision-making process designed to perceive hazards systematically, assess the degree of risk associated with the hazard, and determine the best course of action. See Appendix F. For example, the Perceive, Process, Perform 3P model for aeronautical decision-making, ADM, offers a simple, practical, and structured way for pilots to manage risk. Figure 9-5. To use the 3P model, the pilot perceives the given set of circumstances for a flight, processes by evaluating the impact of those circumstances on flight safety, performs by implementing the best course of action. In the first step, the goal is to develop situational awareness by perceiving hazards, which are present events, objects, or circumstances that could contribute to an undesired future event. In this step, the pilot systematically identifies and lists hazards associated with all aspects of the flight: pilot, aircraft, environment, and external pressures. It is important to consider how individual hazards might combine. Consider, for example, the hazard that arises when a new instrument pilot with no experience in actual instrument conditions wants to make a cross-country flight to an airport with low ceilings in order to attend an important business meeting. In the second step, the goal is to process this information to determine whether the identified hazards constitute risk, which is defined as the future impact of a hazard that is not controlled or eliminated. The degree of risk posed by a given hazard can be measured in terms of exposure, number of people or resources affected, severity, extent of possible loss, and probability, the likelihood that a hazard will cause a loss. If the hazard is low ceilings, for example, the level of risk depends on a number of other factors, such as pilot training and experience, aircraft equipment, and fuel capacity. In the third step, the goal is to perform by taking action to eliminate hazards or mitigate risk, and then continuously evaluate the outcome of this action. With the example of low ceilings at destination, for instance, the pilot can perform good ADM by selecting a suitable alternate, knowing where to find good weather, and carrying sufficient fuel to reach it. This course of action would mitigate the risk. The pilot also has the option to eliminate it entirely by waiting for better weather. Once the pilot has completed the 3P decision process and selected a course of action, the process begins again because the set of circumstances brought about by the course of action requires analysis. The decision-making process is a continuous loop of perceiving, processing, and performing. It is never too early to start teaching students about risk management. Using the 3P model gives CFIs a tool to teach them a structured, efficient, and systematic way to identify hazards, assess risk, and implement effective risk controls. Practicing risk management needs to be as automatic in general aviation, GA, flying, as basic aircraft control. Consider making the 3P discussion a standard feature of the pre-flight discussion. As is true for other flying skills, risk management habits are best developed through repetition and consistent adherence to specific procedures. A hazard list for aviation technicians. AMTs should learn about risk management early in training also. Instructors tasked with integrating risk management into instruction can turn to hazard assessments that identify the safety risks associated with the facility being used, the tools used in the procedure, and/or the job being performed. The process for identifying hazards can be accomplished through the use of checklists, lessons learned, compliance inspections/audits, accidents/near misses, regulatory developments, and brainstorming sessions. For example, aviation accident reports from the National Transportation Safety Board, NTSB, can be used to generate discussions pertaining to faulty maintenance that led to aircraft accidents. All available sources should be used for identifying, characterizing, and controlling safety risks. The 3P model can also be adapted for use in a non-flight environment, such as a maintenance facility. For example, the AMT perceives a hazard, processes its impact on shop or personnel safety, and then performs by implementing the best course of action to mitigate the perceived risk. Pilot self-assessment. Setting personal minimums is an important step in mitigating risk, and safe pilots know how to properly self-assess. For example, in the opening scenario, the aircraft Mary plans to fly may have a maximum crosswind component of 15 knots, listed in the Aircraft Flight Manual, AFM, but she only has experience with 10 knots of direct crosswind. It could be unsafe to exceed a 10-knot crosswind component without additional training. Therefore, the 10-knot crosswind experience level is Mary's personal limitation until additional training with Daniel provides her with the additional experience for flying in crosswinds that exceed 10 knots. Pilots in training must be taught that exercising good judgment begins prior to taking the controls of an aircraft. Often, pilots thoroughly check their aircraft to determine airworthiness, yet do not evaluate their own fitness for flight. Just as a checklist is used when pre-flighting an aircraft, a personal checklist based on such factors as experience, currency, and comfort level can help determine if a pilot is prepared for a particular flight. The FAA's Personal Minimums Checklist, located in Appendix D, is an excellent tool for pilots to use in self-assessment. This checklist reflects the PAVE approach to risk mitigation discussed in the previous paragraphs. Worksheets for a more in-depth risk assessment are located in the FAA/Industry Training Standards Personal and Weather Risk Assessment Guide, located online at www.faa.gov. This guide is designed to assist pilots in developing personal standardized procedures for accomplishing PIC responsibilities and in making better pre-flight and in-flight weather decisions. CFIs should stress that frequent review of the personal guide keeps the information fresh and increases a pilot's ability to recognize the conditions in which a new risk assessment should be made, a key element in the decision-making process. End of Part 1 of Chapter 9. Part 2 of Chapter 9 of Aviation Instructor's Handbook by the FAA This LibriVox recording is in the public domain. Situational Awareness. Situational awareness is the accurate perception and understanding of all the factors and conditions within the four fundamental risk elements that affect safety before, during, and after the flight. Maintaining situational awareness requires an understanding of the relative significance of these factors and their future impact on the flight. When situationally aware, the pilot has an overview of the total operation and is not fixated on one perceived significant factor. Some of the elements inside the aircraft to be considered are the status of the aircraft systems, pilot, and passengers. In addition, an awareness of the environmental conditions of the flight, such as spatial orientation of the aircraft and its relationship to terrain, traffic, weather, and airspace, must be maintained. To maintain situational awareness, all of the skills involved in ADM are used. For example, an accurate perception of the pilot's fitness can be achieved through self-assessment and recognition of hazardous attitudes. A clear assessment of the status of navigation equipment can be obtained through workload management. And establishing a productive relationship with ATC can be accomplished by effective resource use. Obstacles to maintaining situational awareness. Many obstacles exist that can interfere with a pilot's ability to maintain situational awareness. For example, fatigue, stress, or work overload can cause the pilot to fixate on a single perceived important item rather than maintaining an overall awareness of the flight situation. A contributing factor in many accidents is a distraction, which diverts the pilot's attention from monitoring the instruments or scanning outside the aircraft. Many flight deck distractions begin as a minor problem, such as a gauge that is not reading correctly, but result in accidents as the pilot diverts attention to the perceived problem and neglects to properly control the aircraft. Fatigue, discussed as an obstacle to learning, is also an obstacle to maintaining situational awareness. It is a threat to aviation safety because it impairs alertness and performance. Figure 9-5. The term is used to describe a range of experiences from sleepy or tired to exhausted. Two major physiological phenomena create fatigue: sleep loss and circadian rhythm disruption. Fatigue is a normal response to many conditions common to flight operations because characteristics of the flight deck environment, such as low barometric pressure, humidity, noise, and vibration, make pilots susceptible to fatigue. The only effective treatment for fatigue is adequate sleep. As fatigue progresses, it is responsible for increased errors of omission, followed by errors of commission, and microsleeps, or involuntary sleep lapses lasting from a few seconds to a few minutes. For obvious reasons, errors caused by these short absences can have significant hazardous consequences in the aviation environment. Sleep-deprived pilots may not notice sleepiness or other fatigue symptoms during pre-flight and departure flight operations. Once underway and established on altitude and heading, sleepiness and other fatigue symptoms tend to manifest themselves. Extreme fatigue can cause uncontrolled and involuntary shutdown of the brain. Regardless of motivation, professionalism, or training, an individual who is extremely sleepy can lapse into sleep at any time, despite the potential consequences of inattention. There are a number of countermeasures for coping with fatigue, as shown in Figure 9-6. Figure 9-6, Text. Countermeasures for coping with fatigue. Long naps, 3 to 4 hours, can restore alertness for 12 to 15 hours. Short power naps, 10 to 30 minutes, restore alertness for 3 to 4 hours. Eat high-protein meals. Drink plenty of fluids, especially water. Rotate flight tasks and converse with other crew members or passengers. Keep the flight deck temperature cool. Move/stretch in the seat, and periodically get up to walk around the aircraft if possible. Note: allow 15 to 20 minutes after awakening to become fully alert before assuming aircrew duties. End of Figure 9-6 text. Complacency presents another obstacle to maintaining situational awareness. Defined as overconfidence from repeated experience on a specific activity, complacency has been implicated as a contributing factor in numerous aviation accidents and incidents. Like fatigue, complacency reduces the pilot's effectiveness in the flight deck. However, complacency is harder to recognize than fatigue, since everything is perceived to be progressing smoothly. Highly reliable automation has been shown to induce overconfidence and complacency. This can result in a pilot following the instructions of the automation even when common sense suggests otherwise. If the pilot assumes the autopilot is doing its job, he or she does not cross-check the instruments or the aircraft's position frequently. If the autopilot fails, the pilot may not be mentally prepared to fly the aircraft manually. Instructors should be especially alert to complacency in students with significant flight experience. For example, a pilot receiving a flight review in a familiar aircraft may be prone to complacency. Advanced avionics have created a high degree of redundancy and dependability in modern aircraft systems, which can promote complacency and inattention. During flight training, the CFI should emphasize that flight operations may lead to a sense of complacency, which can threaten flight safety by reducing situational awareness. By asking about positions of other aircraft in the traffic pattern, engine instrument indications, and the aircraft's location in relation to references on a chart, the instructor can determine if the student is maintaining situational awareness. The instructor can also attempt to focus the student's attention on an imaginary problem with the communication or navigation equipment. The instructor should point out that situational awareness is not being maintained if the student diverts too much attention away from other tasks, such as controlling the aircraft or scanning for traffic. These are simple exercises that can be done throughout flight training, which help emphasize the importance of maintaining situational awareness. Operational pitfalls. There are numerous classic behavioral traps that can ensnare the unwary pilot. Pilots, particularly those with considerable experience, try to complete a flight as planned, please passengers, and meet schedules. This basic drive to demonstrate achievements can have an adverse effect on safety and can impose an unrealistic assessment of piloting skills under stressful conditions. These tendencies ultimately may bring about practices that are dangerous and sometimes illegal, and may lead to a mishap. Students develop awareness and learn to avoid many of the operational pitfalls through effective ADM training. The scenarios and examples provided by instructors during ADM instruction should involve these pitfalls. Figure 9-7. Single Pilot Resource Management, SRM. Single Pilot Resource Management, SRM, is defined as the art and science of managing all the resources, both on board the aircraft and from outside sources, available to a single pilot prior to and during flight to ensure the successful outcome of the flight. SRM includes the concepts of ADM, Risk Management, RM, Task Management, TM, Automation Management, AM, Controlled Flight into Terrain, CFIT, awareness, and Situational Awareness, SA. SRM training helps the pilot maintain situational awareness by managing the automation and associated aircraft control and navigation tasks. This enables the pilot to accurately assess and manage risk and make accurate and timely decisions. SRM is all about helping pilots learn how to gather information, analyze it, and make decisions. Although the flight is coordinated by a single person and not an onboard flight crew, the use of available resources such as air traffic control, ATC, and automated flight service station, AFSS, replicates the principles of CRM. SRM and the 5P check. SRM is about gathering information, analyzing it, and making decisions. Learning how to identify problems, analyze the information, and make informed and timely decisions is not as straightforward as the training involved in learning specific maneuvers. Learning how to judge a situation and how to think in the endless variety of situations encountered while flying out in the real world
is more difficult. There is no one right answer to ADM. Rather, each pilot is expected to analyze each situation in light of experience level, personal minimums, and current physical and mental readiness level, and make his or her own decision. SRM sounds good on paper, but it requires a way for pilots to understand and use it in their daily flights. One practical application is called the 5 Ps, Figure 9-8. The 5 Ps consist of the plan, the plane, the pilot, the passengers, and the programming. Each of these areas consists of a set of challenges and opportunities that face a single pilot, and each can substantially increase or decrease the risk of successfully completing the flight based on the pilot's ability to make informed and timely decisions. The 5 Ps are used to evaluate the pilot's current situation at key decision points during the flight, or when an emergency arises. These decision points include pre-flight, pre-takeoff, hourly or at the midpoint of the flight, pre-descent, and just prior to the final approach fix, or for visual flight rules, VFR operations, just prior to entering the traffic pattern. The 5 Ps are based on the idea that the pilot has essentially 5 variables that impact his or her environment and that can cause the pilot to make a single critical decision, or several less critical decisions, that when added together can create a critical outcome. This concept stems from the belief that current decision-making models tend to be reactionary in nature. A change must occur and be detected to drive a risk management decision by the pilot. For instance, many pilots use risk management sheets that are filled out by the pilot prior to takeoff. These form a catalog of risks that may be encountered that day and turn them into numerical values. If the total exceeds a certain level, the flight is altered or canceled. Informal research shows that while these are useful documents for teaching risk factors, they are almost never used outside of formal training programs. The 5P concept is an attempt to take the information contained in those sheets and in other available models and use it. The 5P concept relies on the pilot to adopt a scheduled review of the critical variables at points in the flight where decisions are most likely to be effective. For instance, the easiest point to cancel a flight due to bad weather is before the pilot and passengers walk out the door to load the aircraft. So the first decision point is pre-flight in the flight planning room, where all the information is readily available to make a sound decision, and where communication and fixed-based operator FBO services are readily available to make alternate travel plans. The second easiest point in the flight to make a critical safety decision is just prior to takeoff. Few pilots have ever had an emergency takeoff. While the point of the 5P check is to help the pilot fly, the correct application of the 5P before takeoff is to assist in making a reasoned go, no-go decision based on all the information available. These 2 points in the process of flying are critical go, no-go points in each and every flight. The third place to review the 5 Ps is at the midpoint of the flight. Often, pilots may wait until the Automated Terminal Information Service, ATIS, is in range to check weather. Yet, at this point in the flight, many good options have already passed behind the aircraft and pilot. Additionally, fatigue and low-altitude hypoxia serve to rob the pilot of much of his or her energy by the end of a long and tiring flight day. This leads to a transition from a decision-making mode to an acceptance mode on the part of the pilot. If the flight is longer than 2 hours, the 5P check should be conducted hourly. The last 2 decision points are just prior to descent into the terminal area and just prior to the final approach fix, or, if VFR, just prior to entering the traffic pattern, as preparations for landing commence. Most pilots execute approaches with the expectation they will land out of the approach every time. A healthier attitude requires the pilot to assume that changing conditions, the 5 Ps again, will cause the pilot to divert or execute the missed approach on every approach. This keeps the pilot alert to all conditions that may increase risk and threaten the safe conduct of the flight. Diverting from cruise altitude saves fuel,
allows unhurried use of the autopilot, and is less reactive in nature. Diverting from the final approach fix, while more difficult, still allows the pilot to plan and coordinate better rather than executing a futile missed approach. Let's look at a detailed discussion of each of the 5 P's. The plan. The plan can also be called the mission or the task. It contains the basic elements of cross-country planning: weather, route, fuel, publications currency, etc. The plan should be reviewed and updated several times during the course of the flight. A delayed takeoff due to maintenance, fast-moving weather, and a short-notice temporary flight restriction, TFR, may all radically alter the plan. The plan is not only about the flight plan, but also all the events that surround the flight and allow the pilot to accomplish the mission. The plan is always being updated and modified and is especially responsive to changes in the other 4 remaining P's. If for no other reason, the 5P check reminds the pilot that the day's flight plan is real life and subject to change at any time. Obviously, weather is a huge part of any plan. The addition of real-time data link weather information give the advanced avionics pilot a real advantage in inclement weather, but only if the pilot is trained to retrieve and evaluate the weather in real time without sacrificing situational awareness. And of course, weather information should drive a decision, even if that decision is to continue on the current plan. Pilots of aircraft without data link weather should get updated weather in flight through an AFSS and/or Flight Watch. The plane. Both the plan and the plane are fairly familiar to most pilots. The plane consists of the usual array of mechanical and cosmetic issues that every aircraft pilot, owner, or operator can identify. With the advent of advanced avionics, the plane has expanded to include database currency, automation status, and emergency backup systems that were unknown a few years ago. Much has been written about single-pilot IFR flight, both with and without an autopilot. While this is a personal decision, it is just that, a decision. Low IFR in a non-autopilot equipped aircraft may depend on several of the other P's to be discussed. Pilot proficiency, currency, and fatigue are among them. The pilot. Flying, especially when used for business transportation, can expose the pilot to high-altitude flying, long distance and endurance, and more challenging weather. An advanced avionics aircraft, simply due to its advanced capabilities, can expose a pilot to even more of these stresses. The traditional "I'm safe" checklist is a good start. The combination of late night, pilot fatigue, and the effects of sustained flight above 5,000 feet may cause pilots to become less discerning, less critical of information, less decisive, and more compliant and accepting. Just as the most critical portion of the flight approaches, for instance, a night instrument approach in the weather after a 4-hour flight, the pilot's guard is down the most. The 5P process helps a pilot recognize the physiological situation at the end of the flight before takeoff and continues to update personal conditions as the flight progresses. Once risks are identified, the pilot is in an infinitely better place to make alternate plans that lessen the effect of these factors and provide a safer solution. The passengers. One of the key differences between CRM and SRM is the way passengers interact with the pilot. The pilot of a high-capability single-engine aircraft has entered into a very personal relationship with the passengers. In fact, the pilot and passengers sit within an arm's reach all of the time. The desire of the passengers to make airline connections or important business meetings enters easily into this pilot's decision-making loop. Done in a healthy and open way, this can be a positive factor. Consider a flight to Dulles Airport and the passengers, both close friends and business partners, need to get to Washington, D.C. for an important meeting. The weather is VFR all the way to Southern Virginia, then turns to low IFR as the pilot approaches Dulles. A pilot employing the 5P approach might consider reserving a rental car at an airport in northern North Carolina
or Southern Virginia to coincide with a refueling stop. Thus, the passengers have a way to get to Washington, and the pilot has an out to avoid being pressured into continuing the flight if the conditions do not improve. Passengers can also be pilots. If no one is designated as pilot in command, PIC, and unplanned circumstances arise, the decision-making styles of several self-confident pilots may conflict. Pilots also need to understand that non-pilots may not understand the level of risk involved in the flight. There is an element of risk in every flight. That is why SRM calls it risk management, not risk elimination. While a pilot may feel comfortable with the risk present in a night IFR flight, the passengers may not. A pilot employing SRM should ensure the passengers are involved in the decision-making and given tasks and duties to keep them busy and involved. If, upon a factual description of the risks present, the passengers decide to buy an airline ticket or rent a car, then a good decision has generally been made. This discussion also allows the pilot to move past what he or she thinks the passengers want to do and find out what they actually want to do. This removes self-induced pressure from the pilot. The programming. The advanced avionics aircraft adds an entirely new dimension to the way general aviation aircraft are flown. The electronic instrument displays, GPS, and autopilot reduce pilot workload and increase pilot situational awareness. While programming and operation of these devices are fairly simple and straightforward, unlike the analog instruments they replace, they tend to capture the pilot's attention and hold it for long periods of time. To avoid this phenomenon, the pilot should plan in advance when and where programming for approaches, route changes, and airport information gathering should be accomplished, as well as times it should not. Pilot familiarity with the equipment, the route, and the local air traffic control environment, and personal capabilities vis-a-vis the automation should drive when, where, and how the automation is programmed and used. The pilot should also consider what his or her capabilities are in response to last-minute changes of the approach and the reprogramming required, and ability to make large-scale changes, a reroute for instance, while hand-flying the aircraft. Since formats are not standardized, simply moving from one manufacturer's equipment to another should give the pilot pause and require more conservative planning and decisions. The SRM process is simple. At least 5 times before and during the flight, the pilot should review and consider plan, the plane, the pilot, the passengers, and the programming, and make the appropriate decision required by the current situation. It is often said that failure to make a decision is a decision. Under SRM and the 5 Ps, even the decision to make no changes to the current plan is made through careful consideration of all the risk factors present. Information management. The volume of information presented in aviation training is enormous, but part of the process of good SRM is a continuous flow of information in and actions out. How a student manages the flow of information definitely has an effect on the relative success or failure of each and every flight, because proper information contributes to valid decisions. SBT plays an important part in teaching the student how to gather pertinent information from all available sources, make appropriate decisions, and assess the actions taken. For a transitioning pilot, the primary flight display, PFD, multifunction display, MFD, and GPS/very high frequency, VHF navigator screens seem to offer too much information presented in colorful menus and submenus. In fact, the student may be overwhelmed and unable to find a specific piece of information. The first critical information management skill for flying with advanced avionics is to understand the system at a conceptual level. Remembering how the system is organized helps the pilot manage the available information. Simulation software and books on the specific system used are of great value in further understanding for both the CFI and the student. Another information management skill is reading. The best strategy for assessing and managing the available information from PFD to navigational charts is to stop, look, and read. The goal is for the student to learn how to monitor, manage, and prioritize the information flow to accomplish specific tasks. Task management, TM. Task management, TM, a significant factor in flight safety, is the process by which pilots manage the many concurrent tasks that must be performed to safely and efficiently fly a modern aircraft. A task is a function performed by a human as opposed to one performed by a machine, e.g., setting the target heading in the autopilot. The flight deck is an environment in which potentially many important tasks compete for pilot attention at a given time. TM determines which of perhaps many concurrent tasks the pilots attend to at any particular point in time. More specifically, TM entails initiation of new tasks, monitoring of ongoing tasks to determine their status, prioritization of tasks based on their importance, status, urgency, and other factors, allocation of human and machine resources to high-priority tasks, interruption and subsequent resumption of lower priority tasks, and termination of tasks that are completed or no longer relevant. Humans have a limited capacity for information. Once information flow exceeds a person's ability to mentally process the information, any additional information becomes unattended or displaces other tasks and information already being processed. Once the information flow reaches its limit, two alternatives exist: shed the unimportant tasks or perform all tasks at less than optimal level. Like an electrical circuit being overloaded, either the consumption must be reduced or a circuit failure is experienced. Once again, SBT helps the student learn how to effectively manage tasks and properly prioritize them. Automation management. Automation management is the demonstrated ability to control and navigate an aircraft by means of the automated systems installed in the aircraft. One of the most important concepts of automation management is knowing when to use it and when not to use it. Ideally, the goal of the flight instructor is to train the student until he or she has learned how to perform PTS maneuvers and procedures in the aircraft using all the available automation and/or the autopilot. However, the flight instructor must ensure the student also knows how to turn everything off and hand fly the maneuver when the safety of the flight is threatened. Advanced avionics offer multiple levels of automation, from strictly manual flight to highly automated flight. No one level of automation is appropriate for all flight situations. But in order to avoid potentially dangerous distractions when flying with advanced avionics, the student must know how to manage the course indicator, the navigation source, and the autopilot. It is important for a student to know the peculiarities of the particular automated system being used. This ensures the student knows what to expect, how to monitor for proper operation, and promptly take appropriate action if the system does not perform as expected. At the most basic level, managing the autopilot means knowing at all times which modes are engaged and which modes are armed to engage. The student needs to verify that armed functions, e.g., navigation tracking or altitude capture, engage at the appropriate time. Automation management is a good place to practice the call-out technique, especially after arming the system to make a change in course or altitude. Teaching decision-making skills. When instructor pilots discuss system safety, they generally worry about the loss of traditional stick and rudder skills. The fear is that emphasis on items such as risk management, ADM, SRM, and situational awareness detracts from the training necessary in developing safe pilots. It is important to understand that system safety flight training occurs in 3 phases. First, there are the traditional stick and rudder maneuvers. In order to apply the critical thinking skills that are to follow, pilots must first have a high degree of confidence in their ability to fly the aircraft. Next, the tenets of system safety are introduced into the training environment as students begin to learn how to best identify hazards, manage risk, and use all available resources to make each flight as safe as possible. This can be accomplished through scenarios that emphasize the skill sets being taught.
Finally, the student is introduced to more complex scenarios, demanding focus on several safety of flight issues. Thus, scenarios should start out rather simply, then progress in complexity and intensity as the student can handle the learning load. A traditional stick and rudder maneuver, such as short field landings, can be used to illustrate how ADM and risk management can be incorporated into instruction. In Phase 1, the initial focus is on developing the stick and rudder skills required to execute this operation safely. These include power and airspeed management, aircraft configuration, placement in the pattern, wind correction, determining the proper aim point and sight picture, etc. By emphasizing these points through repetition and practice, a student eventually acquires the skills needed to execute a short field landing. Phase 2 introduces the many factors that come into play when performing a short field landing, which include runway conditions, no-flap landings, airport obstructions, and rejected landings. The introduction of such items need not increase training times. In fact, all of the hazards or considerations referenced in the short field landing lesson plan may be discussed in detail during the ground portion of the instructional program. For example, if training has been conducted at an airport that enjoys an obstruction-free 6,000-foot runway, consider the implications of operating the same aircraft out of an 1,800-foot strip with an obstruction off the departure end. Add to that additional considerations, such as operating the aircraft at close to its maximum gross weight under conditions of high-density altitude, and now a single training scenario has several layers of complexity. The ensuing discussion provides a valuable training exercise, and it comes with little additional ground and no added flight training. Finally, Phase 3 takes the previously discussed hazards, risks, and considerations and incorporates them into a complex scenario. This forces a student to consider not only a specific lesson item, in this case short field landings, but also requires that it be viewed in the greater context of the overall flight. For example, on a cross-country flight, the student is presented with a realistic distraction, perhaps the illness of a passenger. This forces a diversion to an alternate for which the student has not planned. The new destination airport has 2 runways, the longest of which is closed due to construction. The remaining runway is short, but while less than ideal, should prove suitable for landing. However, upon entering the pattern, the student finds the electrically driven flaps do not extend. The student must consider whether to press on and attempt the landing or proceed to a secondary alternate. If he or she decides to go forward and attempt the landing, this proves an excellent time to test the requisite stick and rudder skills. If the student decides to proceed to a second alternate, this opens new training opportunities. Proceeding further tests cross-country skills, such as navigation, communication, management of a passenger in distress, as well as the other tasks associated with simply flying the aircraft. The outlined methodology simply takes a series of seemingly unrelated tasks and scripts them into a training exercise requiring both mechanical and cognitive skills to complete it successfully. SBT helps the flight instructor effectively teach ADM and risk management. The what, why, and how of SBT has been discussed extensively throughout this handbook. In teaching ADM, it is important to remember the learning objective is for the student to exercise sound judgment and make good decisions. Thus, the flight instructor must be ready to turn the responsibility for planning and execution of the flight over to the student as soon as possible. Although the flight instructor continues to demonstrate and instruct skill maneuvers, when the student begins to make decisions, the flight instructor should revert to the role of mentor and/or learning facilitator. The flight instructor is an integral part of the system's approach to training and is crucial to the implementation of an SBT program, which underlies the teaching of ADM. Remember, for SBT instruction to be effective, it is vital the flight instructor and the student establish the following information: scenario destinations, desired student learning outcomes, desired level of student performance, possible in-flight scenario changes. It is also important for the flight instructor to remember that A good scenario is not a test, will not have a single correct answer, does not offer an obvious answer, engages all three learning domains, is interactive, should not promote errors, should promote situational awareness and opportunities for decision-making, requires time-pressured decisions. The flight instructor should make the situation as realistic as possible. This means the student knows where he or she is going and what transpires on the flight. While the actual flight may deviate from the original plan, it allows the student to be placed in a realistic scenario. The student will plan the flight to include route, destinations, weather, NOTAMs, possible emergency procedures. Since the scenarios may have several good outcomes and a few poor ones, the flight instructor should understand in advance which outcomes are positive and/or negative and give the student the freedom to make both good and poor decisions. This does not mean that the student should be allowed to make an unsafe decision or commit an unsafe act. However, it does allow the students to make decisions that fit their experience level and result in positive outcomes. Teaching decision-making skills has become an integral part of flight training. The word decision is used several times in each PTS, and applicants are judged on their ability to make a decision as well as their ability to perform a task. Thus, it is important for CFIs to remember that decision-making is a component of the PTS. Assessing SRM skills. The student's performance is often assessed only on a technical level. The instructor determines whether maneuvers are technically accurate and that procedures are performed in the right order. In SRM assessment, instructors must learn to assess students on a different level. How did the student arrive at a particular decision? What resources were used? Was risk assessed accurately when a go, no-go decision was made? Did the student maintain situational awareness in the traffic pattern? Was workload managed effectively during a cross-country flight? How does the student handle stress and fatigue? Instructors should continually evaluate student decision-making ability and offer suggestions for improvement. It is not always necessary to present complex situations which require detailed analysis. By allowing students to make decisions about typical issues as they arise throughout the course of training, such as their fitness to fly, weather conditions, and equipment problems, instructors can address effective decision-making and allow students to develop judgment skills. For example, when a discrepancy is found during pre-flight inspection, the student should be allowed to initially determine the action to be taken. Then, the effectiveness of the student's choice and other options that may be available can be discussed. Opportunities for improving decision-making abilities occur often during training. If the tower offers the student a runway that requires landing with a tailwind in order to expedite traffic, the student can be directed to assess the risks involved and asked to present alternative actions to be taken. Perhaps the most frequent choice that has to be made during flight training is the go, no-go decision based on weather. While the final choice to fly lies with the instructor, students can be required to assess the weather prior to each flight and make a go, no-go determination. In addition, instructors should utilize SBT to create lessons that are specifically designed to test whether students are applying SRM skills. Planning a flight lesson in which the student is presented with simulated emergencies, a heavy workload, or other operational problems can be valuable in assessing the student's judgment and decision-making skills. During the flight, student performance can be evaluated for workload and/or stress management. As discussed in Chapter 5, SRM grades are based on these four components. Explain. The student can verbally identify, describe, and understand the risks inherent in the flight scenario. The student needs to be prompted to identify risks and make decisions. Practice. The student is able to identify, understand, and apply SRM principles to the actual flight situation. Coaching, instruction, and/or assistance from the CFI quickly corrects minor deviations and errors identified by the CFI. The student is an active decision maker. Manage Decide. The student can correctly gather the most important data available both within and outside the flight deck, identify possible courses of action, evaluate the risk inherent in each course of action, and make the appropriate decision. Instructor intervention is not required for the safe completion of the flight. Not observed. Any event not accomplished or required. Post-flight collaborative assessment or learner-centered grading, LCG, also discussed in Chapter 5, is a vital component of assessing a student's SRM skills. As a reminder, collaborative assessment includes two parts: learner self-assessment and a detailed assessment by the flight instructor. The purpose of the self-assessment is to stimulate growth in the student's thought processes and, in turn, behaviors. The self-assessment is followed by an in-depth discussion between the flight instructor and the student, which compares the CFI's assessment to the student's self-assessment. An important element of SRM skill assessment is that the CFI provides a clear picture of the progress the student is making during the training. Grading should also be progressive. During each flight, the student should achieve a new level of learning. For Flight 1, the automation management area might be a describe item. By Flight 3, it would be a practice item, and by Flight 5, manage decide item. Chapter Summary. This chapter introduced aviation instructors to the underlying concepts of safety risk management, which the FAA is integrating into all levels of the aviation community. End of Chapter 9. Appendix B of Aviation Instructor's Handbook by the FAA. This LibriVox recording is in the public domain. Appendix B. Developing a Test Item Bank. Developing a test item bank is one of the instructor's most difficult tasks. Besides requiring considerable time and effort, this task demands mastery of the subject, an ability to write clearly, and an ability to visualize realistic situations for use in developing problems. Because it is so difficult to develop good test items, a semi-permanent record of items that have been developed is desirable. One way of preserving test items is to record the test item along with the analysis of each question on a set of cards. If questions are maintained on a computer, provisions should be made to include appropriate analysis gathered, thus creating a useful database. In either case, the result is a pool of test questions. As long as precautions are taken to safeguard the security of test bank items, this collection lightens the instructor's burden of continuously preparing new items. Figure B-1. Written test items. Supply type. Supply type test items require the learner to furnish a response in the form of a word, sentence, or paragraph. The supply type item requires the learner to organize knowledge. It demands an ability to express ideas and is thus valuable in measuring the learner's generalized understanding of a subject. For example, the supply type item on a pre-solo knowledge test can be very helpful in determining whether the pilot in training has adequate knowledge of procedures. There are several disadvantages to supply type items. First, they cannot be graded with reliability. The same test graded by different instructors could be assigned different scores. Even the same test graded by the same instructor on consecutive days might be assigned altogether different scores. Second, supply type items require more time for the learner to complete and more time for the instructor to grade. Selection type. Selection type test items require the learner to select from two or more alternatives. There is a single correct response for each item. It assumes all learners should learn the same thing and relies on rote memorization of facts. Written tests made up of selection type items are highly reliable, meaning that the results would be graded the same regardless of the learner taking the test or the person grading it. In fact, this type of test item lends itself very well to machine scoring. Also, selection type items make it possible to directly compare learner accomplishment. For example, it is possible to compare the performance of learners within one class to learners in a different class, or learners under one instructor with those under another instructor. By using selection type items, the instructor can test on many more areas of knowledge in a given time than could be done by requiring the learner to supply written responses. This increase in comprehensiveness can be expected to increase validity and discrimination. Another advantage is that selection type tests are well adapted to statistical item analysis. True-false. The true-false test consists of a statement followed by the opportunity for the learner to choose whether the statement is true or false. This item type has a wide range of usage. It is well adapted to testing knowledge of facts and details, especially when there are only two possible answers. The chief disadvantage is that true-false questions create the greatest probability of guessing. Also, true-false questions are more likely to utilize rote memory than knowledge of the subject. In general, therefore, true-false questions are not considered valid, i.e., they do not measure what they are intended to measure. To use true-false questions, consider the following guidelines for effective test items. Include only one idea in each statement. Use original statements rather than verbatim text. Make the statement entirely true or entirely false. Avoid the unnecessary use of negatives, which tend to confuse the reader. Underline or otherwise emphasize the negative words if they must be used. Avoid involved statements. Keep wording and sentence structure as simple as possible. Make statements both definite and clear. Avoid the use of ambiguous words and terms, some, any, generally, most times, etc. Use terms which mean the same thing to all learners whenever possible. Avoid absolutes, all, every, only, no, never, etc. These words are known as determiners because they provide clues to the correct answer. Avoid patterns in the sequence of correct responses because learners can often identify the patterns. Make statements brief and approximately same length. State the source of a statement if it is controversial. Sources have differing information. Multiple choice. A multiple choice test item consists of two parts: the stem, which includes the question, statement, or problem, and a list of possible responses. Incorrect answers are called distractors. When properly devised and constructed, multiple choice items offer several advantages that make this type more widely used and versatile than either the matching or the true-false items. Figure B-2. Multiple choice test questions can help determine learner achievement, ranging from acquisition of facts to understanding, reasoning, and ability to apply what has been learned. It is appropriate to use multiple choice when the question, statement, or problem has the following characteristics: built-in and unique solution, such as a specific application of laws or principles. Wording of the item is clearly limiting, so that the learner must choose the best of several offered solutions rather than a universal solution. Several options that are plausible or even scientifically accurate. Several pertinent solutions, with the learner asked to identify the most appropriate solution. Three major challenges are common in the construction of multiple choice test items. One is the development of a question or an item stem that must be expressed clearly and without ambiguity. A second is that the statement of an answer or correct response cannot be refuted. Finally, the distractors must be written in such a way that they are attractive to those learners who do not possess the knowledge or understanding necessary to recognize the keyed response. A multiple choice item stem may take one of several basic forms: a direct question followed by several possible answers, an incomplete sentence followed by several possible phrases that complete the sentence, a stated problem based on an accompanying graph, diagram, or other artwork, followed by the correct response and the distractors. The learner may be asked to select the one correct choice or completion, the choice that is an incorrect answer or completion, or the one choice that is the best answer option presented in the test item. Beginning test writers find it easier to write items in the question form.
In general, the form with the options as answers to a question is preferable to the form that uses an incomplete statement as the stem. It is more easily phrased, and it is more natural for the learner to read. Less likely to contain ambiguities, it usually results in more similarity between the options and gives fewer clues to the correct response. When multiple choice questions are used, 3 or 4 alternatives are generally provided. It is usually difficult to construct more than 4 convincing responses. That is, responses which appear to be correct to a person who has not mastered the subject matter. Learners are not supposed to guess the correct option. They should select an alternative only if they know it is correct. An effective means of diverting the learner from the correct response is to use common learner errors as distractors. For example, if writing a question on the conversion of degrees Celsius to degrees Fahrenheit, providing alternatives derived by using incorrect formulas would be logical, since using the wrong formula is a common learner error. Items intended to measure the rote level of learning should have only one correct alternative. All other alternatives should be clearly incorrect. When items are to measure achievement at a higher level of learning, some or all of the alternatives should be acceptable responses, but one should be clearly better than the others. In either case, the instructions given should direct the learner to select the best alternative. To use multiple choice questions, consider the following guidelines for construction of effective test items. Make each item independent of every other item in the test. Do not permit one question to reveal or depend on the correct answer to another question. Design questions that call for essential knowledge rather than for abstract background knowledge or unimportant facts. State each question in language appropriate to the learners. Include sketches, diagrams, or pictures when they can present a situation more vividly than words. They generally speed the learning process, add interest, and help to avoid reading difficulties and technical language. When a negative is used, emphasize the negative word or phrase by underlining, boldfacing, italicizing, or printing in a different color. Avoid questions containing double negatives, which invariably cause confusion. Avoid trick questions, unimportant details, ambiguities, and leading questions that confuse and antagonize the learner. If attention to detail is an objective, detailed construction of alternatives is preferred to trick questions. Stems. In developing the stem of a multiple choice question, the following principles should be utilized. Figure B-3. The stem should clearly present the central problem or idea. The function of the stem is to set the stage for the alternatives that follow. The stem should contain only material relevant to its solution, unless the selection of what is relevant is part of the problem. The stem should be worded in such a way that it does not give away the correct response. Avoid the use of determiners such as clue words or phrases. Put everything that pertains to all alternatives in the stem of the item. This helps to avoid repetitious alternatives and saves time. Generally avoid using a or an at the end of a stem. This may give away the correct choice. Every alternative should grammatically fit with the stem of the item. Alternatives. The alternatives to a multiple choice test are as important as the stem. They should be formulated with care. Simply being incorrect should not be the only criterion for the distracting alternatives. Popular distractors are an incorrect response related to the situation which sounds convincing, a common misconception, a statement which is true but which does not satisfy the requirements of the problem, a statement that is either too broad or too narrow for the requirements of the problem. Research of instructor-made tests reveals that, in general, correct alternatives are longer than incorrect ones. When alternatives are numbers, they should generally be listed in ascending or descending orders of magnitude or length. Matching. A matching test item consists of 2 lists, which may include a combination of words, terms, illustrations, phrases, or sentences. The learner must match alternatives in one list with related alternatives in a second list. In reality, a matching exercise is a collection of related multiple choice items. In a given period of time, more samples of learners' knowledge usually can be measured with matching rather than with multiple choice items. The matching item is particularly good for measuring a learner's ability to recognize relationships and to make associations between terms, parts, words, phrases, clauses, or symbols listed in one column with related items in another column. Matching reduces the probability of guessing correct responses, especially if alternatives may be used more than once. The testing time can also be used more efficiently. The following guidelines help the construction of effective matching test items. Give specific and complete instructions. Do not make the learner guess what is required. Test only essential information. Never test unimportant details. Use closely related materials throughout an item. If learners can divide the alternatives into distinct groups, the item is reduced to several multiple choice items with few alternatives, and the possibility of guessing is distinctly increased. Make all alternatives credible responses to each element in the first column, whenever possible, to minimize guessing by elimination. Use language the learner can understand. By reducing language barriers, both the validity and reliability of the test is improved. Arrange the alternatives in some sensible order. An alphabetical arrangement is common. Matching type test items are either equal column or unequal column. An equal column test item has the same number of alternatives in each column. When using this form, always provide some letters in the response column to be used more than once, or not at all, to preclude guessing by elimination. Unequal column type tests have more alternatives in the second column than in the first, and are generally preferable to equal columns. End of Appendix B. Appendix C of Aviation Instructor's Handbook by the FAA. This LibriVox recording is in the public domain. Appendix C. Certificates, Ratings, and Endorsements. Flight Instructor Endorsements. The authority and responsibility for flight instructors to endorse initial student certificates, logbooks for solo and solo cross-country, additional aircraft ratings, and flight privileges are outlined in Title 14 of the Code of Federal Regulations, 14 CFR, Part 61. In addition, Advisory Circular AC 61-65, Certification, Pilots and Flight Instructors, and Ground Instructors, provides guidance for pilots, flight instructors, ground instructors, and examiners on the certification standards, knowledge test procedures, and other requirements of 14 CFR Part 61. By utilizing AC 61-65, the flight instructor does not omit any required endorsement for the rating sought, which ensures standardization. It is important for the flight instructor to understand and use AC 61-65 in the certification process. Additionally, flight instructors are required to make an endorsement in the student or applicant's logbook or training record whenever the flight instructor provides flight or ground training. At a minimum, this endorsement should include what actions or instructions were completed and, if any, regulatory requirements were met. Citing the appropriate portion of 14 CFR Part 61 is also recommended. Flight instructors also have the responsibility to make logbook endorsements for pilots who are already certificated, such as sport, recreational, private, commercial, and instrument-rated pilots, as well as flight instructors. Typical endorsements include, but are not limited to, flight reviews, instrument proficiency checks, the additional training required for high-performance, high-altitude, and tailwheel aircraft, and types of glider launches. Additional rating applicants, e.g., multi-engine add-on, seaplane add-on, glider add-on, helicopter add-on, are rated pilots and not considered student pilots in accordance with IAW 14 CFR Part 61. Flight instructors must endorse the applicant's logbook prior to solo flight and prior to being evaluated for that rating with an endorsement from AC 61-65, stating that the applicant is competent to act as the pilot in command, PIC, of an aircraft in which he or she does not hold a category or class rating. The flight instructor may add additional requirements or restrictions to the endorsement, such as an expiration date. Practical test endorsements are addressed in AC 61-65. These endorsements are regulatory and the pilot applicant must comply with them. Flight instructors are responsible for properly documenting a student or applicant's completion of prerequisites for a practical test. Examples of all common endorsements can be found in AC 61-65, Appendix C. Further details about the requirements for each respective endorsement can be found in 14 CFR Part 61. These examples contain the essential elements of each endorsement with the goal of providing guidance and encouraging standardization among instructors. The flight instructor may need to customize the endorsement due to an applicant's special circumstances or changes in regulatory requirements, but it is recommended all endorsements be worded as closely as possible to those in AC 61-65. At a minimum, the flight instructor needs to cite the appropriate 14 CFR Part 61 section that has been completed. Figure C-1. Federal Aviation Administration, FAA inspectors and designated pilot examiners, DPEs, rely on flight instructor recommendations for student or pilot applicant testing. These recommendations are accepted as evidence of qualification for certification and proof that a review of the subject areas found to be deficient on the appropriate knowledge test has been given by the flight instructor. Recommendations also provide assurance the applicant has had a thorough briefing on the Practical Test Standards, PTS, and the associated knowledge areas, maneuvers, and procedures. If the flight instructor has trained and prepared the applicant competently, the applicant should have no difficulty in passing the written and practical tests. Sport Pilot. Many consider the advent of the Sport Pilot certification to be one of the most significant changes to the airman certification structure to have occurred in over 50 years. Because of the growing cost to acquire the private pilot certification, more and more aviation enthusiasts were considering the Sport Pilot as an alternative. Many aircraft already meet the light sport aircraft criteria, and many manufacturers are now producing modern light sport aircraft. It is likely that flight instructors will be asked to provide information and possibly training for this new certificate. Flight instructors should review 14 CFR Part 61, Subparts J and K, for the requirements and privileges and limitations of the Sport Pilot certifications, as well as the new endorsement requirements. Of particular interest has been the medical requirement. Subparts J and K also describe the process for sport pilots and flight instructors with a sport pilot rating to add additional category/class privileges. Since light sport aircraft must meet certain criteria, a well-informed flight instructor would be expected to be acquainted with the basic requirements. FAA Forms 8710-1, 8610-1, and 8710-11. Forms 8710-1, 8610-2, and 8710-11 are the print versions of the Airman Certificate and/or rating application. Again, the instructor ensures the applicant is prepared for the test and has met all regulatory requirements, including knowledge, proficiency, required endorsements, and experience requirements before the application process. The applicant then either completes the 8710 or 8610 paper form by hand or completes a digital computer-based form found on the FAA website. This form is in PDF. Remind the student that while the form can be completed online, the data cannot be saved and the applicant must print a copy before closing the window or the data will be lost. Instructions for completing the form are available on the website. After printing the requisite form, the applicant physically signs it, and then the instructor verifies the information and signs the form, which the DPE mails to the nearest FSDO. Downloadable versions of the FAA Form 8710-1 and 8610-2 are available at www.faa.gov www.faa.gov/library/forms/. Figures C2 and C3 are examples of a private pilot applicant who received training under 14 CFR Part 61. This is only an example, since the form is periodically revised to reflect changes in the applicable rules and regulations. If the current form is a later edition than the one shown here, the instructions must be read very carefully to ensure all areas of the form are filled out correctly. The example shown is annotated with additional guidance to clarify or reinforce certain areas that are frequently found incomplete by the FAA during the certification process. Instructor records. 14 CFR Part 61 requires the flight instructor to maintain a record that includes information of the type of endorsement, the name of the person receiving the endorsement, and the date of the endorsement. This information must be kept in a logbook or a separate document. For a knowledge or practical test endorsement, the record must include the kind of test, the date, and the results. Records of endorsements must be maintained for at least 3 years. Knowledge tests. When preparing an applicant for the private certification or higher grade rating, e.g., commercial or instrument, a test is required to ensure that the student has adequate aeronautical knowledge in those subject areas listed in 14 CFR Part 61. The flight instructor may provide the student with an endorsement to certify he or she has the required knowledge to pass the knowledge test. Some additional ratings do not require a knowledge test. For information concerning additional aircraft certifications that do not require knowledge tests, refer to AC 61-65. Flight instructors must take a short question test for additional category. As a general rule, the following may be determined if a knowledge test for private, commercial, or instrument rating is required, but the flight instructor should review 14 CFR Part 61. If the applicant fails a knowledge test, the flight or ground instructor must sign the written test after he or she has given additional training for a retake of the test. Additional training and endorsements. Flight instructors often provide required training and endorsements for certificated pilots. AC 61-98, currency and additional qualification requirements for certificated pilots, contains information to assist the instructor in providing training/endorsements for flight reviews, instrument proficiency checks, and transitions to other makes and models of aircraft. Included in the AC are general guidance to each of these areas, references to other related documents, and sample training plans that are pertinent to this type of training. Flight reviews. The purpose of the flight review, required by 14 CFR Section 61.56, is to provide for regular evaluation of pilot skills and aeronautical knowledge. According to the regulation, it is also intended to offer pilots the opportunity to design a personal currency and proficiency program in consultation with the CFI. In effect, the flight review is the aeronautical equivalent of a regular medical checkup and ongoing health improvement program. The conduct of flight reviews for certificated pilots is a responsibility of the flight instructor and is also an excellent opportunity for the instructor to expand his or her professional services. The flight review is intended to be an industry-managed, FAA-monitored currency program. The flight review is not a test or a check ride, but an instructional service designed to assess a pilot's knowledge and skills. As stated in 14 CFR Part 61, no person may act as PIC of an aircraft unless a flight review has been accomplished within the preceding 24 calendar months. Effective pilot refresher training must be based on specific objectives and standards. The objectives should include a thorough checkout appropriate to the pilot certificate and aircraft rating held, and the standards should be at least those required for the issuance of a pilot certificate. Before beginning any training, the pilot and the instructor should agree fully on those objectives and standards, and as training progresses, the pilot should be kept appraised of progress toward achieving those goals. A flight review is an excellent opportunity for a certificated flight instructor, CFI, to review pilot decision-making skills.
To get the information needed to evaluate ADM skills, including risk management, give the pilot multiple opportunities to make decisions and ask questions about those decisions. For example, ask the pilot to explain why the alternate airport selected for the diversion exercise is a safe and appropriate choice. What are the possible hazards, and what can the pilot do to mitigate them? Be alert to the pilot's information and automation management skills as well. For example, does the pilot perform regular common-sense cross-checks? For more ideas in generating scenarios that teach risk management, visit www.faa.gov/library/manuals/pilot_risk/. AC61-98 Currency and Additional Qualification Requirements for Certificated Pilots, Chapter 1, provides guidance for conducting the flight review. Appendix B is a sample flight review plan and checklist. Appendix C is a sample of flight review knowledge, maneuvers, and procedures, and it contains recommended procedures and standards for general pilot refresher courses. At the conclusion of a successful flight review, the logbook of the pilot should be endorsed as recommended by AC 61-65, Figure 4-C. In addition to the required maneuvers conducted during the flight review, flight instructors should also review and discuss those special emphasis items listed in the Flight Instructor PTS. Instrument Proficiency Checks. Instrument-rated pilots who have not met instrument currency requirements in the preceding 6 months or for 6 months thereafter are required by 14 CFR Part 61 to pass an instrument proficiency check ride in order to regain their instrument flying privileges. AC 61-98 contains guidance for the conduct of an instrument proficiency check, including a sample plan of action and checklist. The primary reference for specific maneuvers and any associated tolerances for an instrument proficiency check ride is the Instrument Rating PTS, which includes a matrix table of required operations and tasks. A pilot taking an instrument proficiency check is expected to meet the criteria of the specific tasks selected in the Instrument Rating PTS. Aircraft and instrument ratings appropriate to the aircraft being flown must be listed on the flight instructor's instructor certificate. Part or all of the check may be conducted in a flight training device or flight simulator that meets 14 CFR Part 141.41 requirements. The FAA FSDO, having jurisdiction over the area where the device is used, must specifically approve each flight training device or flight simulator. If planning to use a flight training device or flight simulator to conduct all or part of an instrument proficiency check, instructors should contact the local FSDO to verify the approval status of the device. Aircraft checkouts/transitions. Certificated pilots depend on flight instructors for aircraft checkouts and transition training, including high-performance airplanes, tailwheel airplanes, motor gliders, and aircraft capable of flight at high altitudes. The flight instructor who checks out and certifies the competency of a pilot in an aircraft for which type rating is not required by regulations is accepting a major responsibility for the safety of future passengers. Many newer light airplanes are comparable in performance and complexity to transport airplanes. For these, the flight instructor's checkout should be at least as thorough as an official type rating practical test. Other considerations include AC 61-98 provides a list of requirements for transitioning to other makes and models of aircraft, along with a sample training plan. AC 61-98 also lists other publications that can be useful in conducting checkouts. All checkouts should be conducted to the performance standards required by the appropriate PTS for the pilot certificate. For motor glider transition training, refer to AC 61-94, Pilot Transition Course for Self-Launching or Powered Sailplanes, Motor Gliders. Flight instructors should ensure they meet the recommendation experience cited in the AC 61-94 to conduct this special qualification. For the conduct of an aircraft checkout, it is essential the flight instructor is fully qualified in the aircraft used
and thoroughly familiar with its operating procedures, AFM, and operating limitations. An instructor who does not meet the recent flight experience prescribed by regulations for the aircraft concerned should not attempt to check out another pilot. The flight instructor should utilize a plan of action and a written training syllabus based on the appropriate PTS and record in the pilot's logbook the exact extent of any checkout conducted. This record serves a twofold purpose. It benefits the pilot concerned, and it protects the flight instructor if questions arise later. In the event the instructor finds a pilot's performance to be insufficient to allow sign-off, the pilot should be thoroughly debriefed on all problem areas and further instruction scheduled. In some cases, a referral to another instructor may be appropriate. Pilot proficiency. Professional flight instructors maintain knowledge and skill as instructors and as pilots. The flight instructor is at the leading edge of the aviation industry's efforts to improve aviation safety through additional training. The FAA encourages instructor-pilot proficiency in two ways: by requiring a flight instructor to renew his or her certificate every 24 months, by the Pilot Proficiency Award Program, described in AC 61-91. Endorsements. Application for airman certification and/or rating. In order to improve the application process, the FAA is moving from a paper-based method of application to an internet method. Although the application form for pilots and mechanics are available for download at www.faa.gov/library/forms/, the FAA encourages aviation instructors to become familiar with the internet method described below. Integrated Airman Certification and/or Rating Application, IACRA. In the fall of 2003, the FAA released the Integrated Airman Certification and/or Rating Application, an internet-based database program providing a fully electronic method of applying for an airman certification or rating, located at http://acra.faa.gov/IACRA/. It electronically captures and validates airman information required to complete the airman application. IACRA can be accessed from any location with internet connectivity. Figure C-5. IACRA interfaces with multiple FAA national databases to validate data and verify specific fields. IACRA automatically ensures applicants meet regulatory and policy requirements through business rules and data validation. It implements the use of digital signatures throughout the certification process. IACRA automatically forwards the 8710 application and test results to the Airman Registry. IACRA replaces the Airman Certification and/or Rating Application, CD, ACRA, a standalone computer-based PC program that was the FAA's first effort to automate the application process. With new paths of application added weekly, the IACRA program team continues to develop IACRA's capability. Currently, the program can process virtually all pilot applications from Sport Pilot through Airline Transport Pilot, ATP, type ratings, certificated flight instructors, mechanics, and most repairmen. If the applicant chooses to complete the Airman Certificate and/or Rating application using IACRA, the instructor should ensure the applicant is prepared for the test and has met all the regulatory requirements, including knowledge, proficiency, required endorsements, and experience requirements. Suggest the applicant visit the IACRA site, review the frequently asked questions, and read the document Getting Started Desktop Instructions before completing an application. Stress the importance of the applicant having all pertinent information readily available before logging on. If the applicant has all necessary information available, the process should not take over 10 minutes. Remind the applicant the instructor can supervise the application process, or the instructor can log on to IACRA anytime after the applicant has completed the initial process and call up the application based on the FAA tracking number, FTN, assigned to the applicant. When using IACRA, The applicant must complete the applicant's section, and the instructor certifies the applicant's information. An online public accessible training center for IACRA hosted by the FAA Safety Team, FAA-STEAM, FAST Team, at http://faasafety.gov is under development. When operational, there will be a link on the IACRA website to the training center. A number of different training aids to include the fully interactive Practice IACRA program will be available. This program will enable the instructor to fill out practice applications, review them, and sign them off, giving the instructor a better feel for the entire process. Student Pilot Endorsements. Title 14 of the Code of Federal Regulations, 14 CFR, Section 61.189, requires instructors to sign the logbook of each person they have given ground or flight training. Advisory Circular AC 61-65 contains suggested endorsements, and this appendix reprints several of the more commonly used endorsements. See pages C-8 and C-9. All of these examples contain the essential elements, but it is not necessary for endorsements to be worded exactly as those in the AC. For example, changes to regulatory requirements may affect the wording, or the instructor may customize the endorsements for any special circumstances of the student. Certificates, ratings, and endorsements. Certificates. The basic airman qualifications document that the FAA issues is called a certificate. The pilot certificate level depends upon the extent of training and testing required. The FAA separately issues instructor certificates. A pilot certificate, commercial or ATP, is required to exercise the privileges of some, but not all, instructor certificates. See figure, page C-10. Ratings. Except for student and sport pilot certificates, all pilot and instructor certificates have associated ratings. A rating specifies what and or how the pilot is qualified to fly. There are several kinds of ratings. See figure, page C-10. There are many possible combinations of certificates and ratings for aircraft category and class. For example, you might have a commercial pilot certificate with an airplane single-engine land rating. If you train and test in a multi-engine airplane to the private pilot certificate level rather than the commercial level, you will still have a commercial pilot certificate with an airplane single-engine land rating, but it will note that you have a multi-engine land rating with private pilot privileges. Endorsements. An endorsement attests to the completion of ground and or flight training required for specific operating privileges or for airman certification testing. Except for certain endorsements made in pen and ink on a student pilot certificate, the endorsements required by 14 CFR Part 61 fall into several broad categories. Student pilots. Because a student pilot certificate has no aircraft category and class rating, operating privileges and limitations for solo flight are conveyed exclusively through instructor endorsements. Endorsements in this category are usually limited not just to aircraft category and class, but also to a specific make and model. Student pilot endorsements can also specify weather limitations. Sport pilots. Like a student pilot certificate, a sport pilot certificate is issued without aircraft category and class ratings. Logbook endorsements specify the category, class, make, and model of aircraft that the sport pilot is authorized to fly as pilot in command. Testing for a certificate or rating. To take a knowledge test or practical test for most pilot certificates and ratings, the applicant must have endorsements attesting to aeronautical knowledge and flight proficiency, including aeronautical experience and practical test preparations required in 14 CFR 61.31A6. The flight instructor applicant endorsements for completing the fundamentals of instruction and spin training fall into this category as well. Recurrent training. To maintain the operating privileges conferred by a pilot certificate or instrument rating,
The pilot must have an endorsement for satisfactory completion of required recurrent training, e.g., flight review or instrument proficiency check. Aircraft characteristics. The requirement for a type rating is limited to large, greater than 12,500 pounds, MGTOW, maximum gross takeoff weight, and turbojet power aircraft. However, certain small and piston-powered aircraft have characteristics that require additional training for safe operation. For example, 14 CFR 61.69 specifies training and experience required for towing a glider. Specific additional aircraft training requirements are outlined in 14 CFR 61.31, and instructor endorsements that attest to the satisfactory completion of this training or a mechanism used to confer the necessary operating privilege. Endorsements related to aircraft characteristics include those for complex, high-performance, high-altitude, tailwheel, and glider ground operations. In addition, 14 CFR 61.31H provides for additional aircraft type specific training in cases where the FAA has determined that such training is required. End of Appendix C. Appendix D of Aviation Instructor's Handbook by the FAA. This LibriVox recording is in the public domain. Appendix D, Personal Minimums Checklist. Your Personal Minimums Checklist is an easy-to-use personal tool tailored to your level of skill, knowledge, and ability. It helps you control and manage risk by identifying even subtle risk factors. Allows you to fly with less stress and less risk. Practice conservatism without guilt. Each item provides you with either a space to complete a personal minimum or a checklist item to think about. Spend some quiet time completing each blank and consider other items that apply to your personal minimums. Give yourself permission to choose higher minimums than those specified in the regulations, aircraft flight manuals, or other rules. How to use your checklist. Use this checklist just as you would use one for your aircraft. Carry the checklist in your flight kit. Use it at home as you start planning a flight, and again, just before you make your final decision to fly. Be wary if you have an item that's marginal in any single risk category. But if you have items in more than one category, you may be headed for trouble. If you have marginal items in two or more risk factor/categories, do not go. Periodically review and revise your checklist as your personal circumstances change, such as your proficiency, recency, or training. You should never make your minimums less restrictive unless a significant positive event has occurred. However, it is okay to make your minimums more restrictive at any time. And never make your minimums less restrictive when you are planning a specific flight, or else external pressures will influence you. See Appendix D for example, Personal Minimums Checklist. Have a fun and safe flight. End of Appendix D. End of the Aviation Instructor's Handbook FAA-H-8083-9A by the U.S. Department of Transportation, Federal Aviation Administration, FAA, Flight Standards Service. Reader's Note. For the figures, tables, reference material, glossary, and index, the listener is referred to the public domain handbook available from the FAA.gov website, www.faa.gov/regulations_policies/handbooks_manuals/ Recording by Norman Elfer, Pearl River, Louisiana, USA.